This video is a full tutorial of learning C# programming language for beginners that also includes introduction to object-oriented programming concept. Before you start learning AutoCAD .NET API programming, you need to have a good understanding of C# language, and this video provides you that. By the way, this is part of my course on Udemy, AutoCAD Programming using C#.NET beginner course, if you are interested. Okay, so I hope you enjoy this tutorial. Welcome to section 3, C# fundamentals. In this section, we will cover the many important features of C# programming language. The first one is the data types and variables. We will learn what are the different data types and variables in C# and their usage in the program. The next one is operators. We will explore the many types of operators and their respective usage. Keywords. There are many different keywords, and these are also called as reserved words, and we will see all of them. The fourth one is modifiers. We will identify what are the different modifier keywords. Conditionals. We will understand how to use the if then else as well as the switch constructs. Loops. There are many different ways to loop in C#, and we will explore all of them. Debugging. We will walk through the process of debugging and creating a breakpoint and watches, so we can track what's happening on the data before and after they are processed or used in the program. Next is the error handling. This is very important part of programming to handle different types of errors. We will learn the try-catch finally block and how we can apply it in our program. The last one is the introduction to object-oriented programming, or OOP. In this lecture, we will discuss how the three main concepts of OOP, which are encapsulation, inheritance, and polymorphism. So in each of these subjects, we will have a demo, so you will have a better understanding on how they work and how to apply them in your coding. So let's go ahead and start with the data types and variables in the next video. Let us now start with the data types and variables. In C# there are two different data types. The first one is value type, which means that a data type that holds the data within its own memory allocation. And the other one is the reference type. This is a data type that contains a pointer to another memory location that holds the data. So basically, the value type stores its contents in memory allocated on the stack. Stack means is used for static memory allocation. So when you created a value type, a single space in memory is allocated to store the value, and that variable directly holds a value. If you assign it to another variable, the value is copied directly, and both variables work independently. While the reference type, because it represents the address of the variable rather than the data itself, assigning a reference variable to another doesn't copy the data. Instead, it creates a second copy of the reference, which refers to the same location of the heap as the original value. The heap means it is used for dynamic memory allocation. These are the value types. So value types has two different types. It has a signed integer and the other one is unsigned integer. So for the signed integer, we have here the S byte, which is equivalent to 8 bits. 1 byte is equal to 8 bits, and it has a range of -128 to +127. Short, it has a value of 16 bits, equivalent to 2 bytes, and it ranges from -32,768 to +32,767. The next one is the int or integer. It has 32 bits, and it has this value that ranges into billion. And the long has 64 bits, and this is the range from this is quintillion to +9 quintillion. It's a massive amount of data. Now the unsigned integer, we have here the byte, which is 8 bits, and the range is from 0 to 255. So the unsigned integer means it starts from 0. So basically these values here is the total of each of these data type. So for the S byte, it's equivalent to basically 255. The U short is equivalent to 65,535. And same with the U int, which is 32 bits, and this is the range from 0 to 4,294,967,295. And the unsigned long, it has 64 bits, and it ranges from 0 to 18 quintillion something. So those are the different value types for both signed and unsigned integers. In the next video, we're going to explore the floating point and the decimal data type. I'll see you there. Let us now have a demo of the value types for both the signed integer and the unsigned integer. I have created here a console project called data types. So let's start with the S byte. Let's say I create a variable with an S byte data type. Let's call that SB. So as we know, it has a value of 8 bits, which is has a range of -128 to +127. So if I say 127, the IntelliSense or the IDE does not complain because it's within the range. If I put it at 128, for example, now you notice this red under. It says constant value 128 cannot be converted to a S byte, which means that it's already over the maximum range. If we go to the negative value, we have -128, so it is okay because it's the minimum value that we can assign to it. But if, let's say, we add -1, for example, it became 129, so the IntelliSense also complain about it, which we are already below the allowed minimum range. So we can only assign from -128 to +27. Something like that. And the IntelliSense will not complain. Next, let's check the short data type. So it has a 16 bits, and the maximum is, the range is starts from negative 32,768 to 32,767. So let's say just sh equals negative 32,768. This is fine. Short sh2 equals 32,767. This is also okay. But if we add another number, same thing that happens here, and also if we increment this by 1, so it's also complaining about the value. It's exceeded the maximum allowed number, hence it cannot convert to a short. Alright, so this is typical to all the data types. If you assign a value that is more than the allowed range, it will give you this problem. So the IntelliSense is actually very smart to identify that those values that's being assigned is already out of range, so you won't be able to compile that. Last one, let's start with the integer as well. So let's say I1 equals, this is the number, it's quite a huge number. So this is valid. Integer I2 equals, we have here the maximum range. This is also valid, but I think we are missing the 2 here. So by just incrementing 1, and let's say another 1 here, compiler or the IDE complained. So this is typical to all the different data types. Now let's just have a quick run through of the unsigned integer, for example. So for the byte we have, like, let's say bt equals 0. This is okay. If we have byte bt2 equals, so it's range from 0 to 255, let's say 256. It complained, but 255 is fine. And for the unsigned short equals 0, this is okay. If we assign -1, it will complain because it doesn't allow the assigned number or a negative number. It starts from 0 to 65535. So this is okay. If I increment by 1, doesn't allow it. So that's it for the data types and variables. You can only assign from within the range that is allowed, from minimum and the maximum. Alright, I hope this is clear, and you have to be mindful of the data type that you are using in your program. I'll see you in the next video. Let us now continue with the remaining value types. We have here the floating point and the decimal. So under the floating point we have 2 types. First one is float and the other one is double. Float has a value of 32 bits equivalent to 8 bytes with a range of 1.5 by 10 to the minus 45 power and a maximum range of 3.4 by 10 to the 38 power. It has a 7-digit precision. And the double we have 64 bits equivalent to 8 bytes with a range of 5.0 by 10 to the negative 324 power with a maximum range of 1.7 by 10 to the 308 power. It has a 15-digit precision. And with the decimal it has a value of 128 bits equivalent to 16 bytes with a range of negative 7.9 by 10 to the negative 28 power with a maximum range of 7.9 by 10 to the 28 power. It has at least 28-digit precision. This makes the decimal more appropriate for financial and monetary calculations because it has a smaller range and more precision. So in the next video we're going to have a demo on how we can use these different data types in our code. Let's use the project data types to demo the float, decimal, and double. So for the float, by default, a real numeric literal on the right side of the assignment operator is treated as double. Therefore, to initialize a float variable, we have to use the suffix small f or capital F. If you don't use that, it will cause an error because this is treated as double. See? Literal of type double cannot be implicitly converted to type float. So you have to specify capital F or small f. The next one is double. So by default, a real numeric literal on the right side of the assignment operator is treated as double. So let's say we have here double dbnum equals 3.5 with or without d, that is valid. But for example, we would like the integer to be treated as double, so we have to make sure that it has a suffix d. Let's say dbnum2 equals a 3 point something like that. If we omit the d, this will be treated as integer, so we make sure that we provide the d, and then it will be interpreted as double. Now for the decimal, if you want a numeric real literal to be treated as decimal, we have to use the suffix m. So for example, I have here my variable my money equals 100.5. Without providing the m, it will give us some compilation error here. So we have to make sure that we provide the money if we are using the decimal data type. Okay? Without this, it will be treated as double also. Literal of type double cannot be implicitly converted to type decimal. So we have to make sure that we have the m here. Alright? By the way, I'm sure you have noticed some of these green color underneath the variables. The reason for this is that it's just haven't been used in the program yet. So let's say decimal total amount, for example, equals my money times 10. This one will disappear. The green line underneath this variable will disappear. So that's just about it for the float, double, and decimal. Let us continue discussing about the value types. Other than the signed or unsigned integers, floating points, and decimals, C# has few more value types. One is bool. It has 8 bits with the value of true and false. So basically, the bool keyword is an alias of system.boolean. It is used to declare variables to store the boolean values, which is true and false. Another value type is char. It has 16 bits. The value is Unicode characters. When you speak of Unicode, it is an international encoding standard for use with different languages and scripts, by which each letter, digit, or symbol is assigned a unique numeric value that applies across different platforms and programs. So the car keyword is used to declare an instance of the system.car structure that the .NET framework uses to represent a unique character. The car object is a 16-bit numeric value. Another type is the date time. It has 64 bits. The value is from 00 AM 1101 to 11:59:59 PM 12:31:9999. It represents an instance in time, typically expressed as a date and time of day. Another type is the struct type. So a struct type is similar to a class type in that it represents a structure with data members and function members. However, unlike classes, structs are value types and do not typically require heap allocation. Struct types do not support inheritance. So the last type is the enum type. The enum keyword is used to declare an enumeration, a distinct type that consists of a set of named constants called the enumerator list. So in the next video, we are going to have an example of all this. I'll see you there. Let us now identify the other data type in C#. So other than the value type, which holds the data within its own memory allocation, there is also a reference type. The reference type contains a pointer to another memory location that holds the data. The reference types are as follows. The first one is class type. A class type defines a data structure that contains data members or fields and function members, for example, methods and properties. Class types support single inheritance and polymorphism, a mechanism whereby derived classes can extend and specialize base classes. The next reference type is the interface type. An interface type defines a contract as a named set of public function members. A class or struct that implements an interface must provide implementations of the interface's function members. An interface may inherit from multiple base interfaces, and a class or struct may implement multiple interfaces. The third reference type is array type. C# supports single and multi-dimensional arrays of any type. Unlike the types listed above, array types do not have to be declared before they can be used. Instead, array types are constructed by following a type name with square brackets. In this example here, int is a single dimensional array of integer, and this declaration with the comma in the middle is a two-dimensional array of integer. The last type is the delegate type. A delegate type represents references to methods with a particular parameter list and return type. Delegates makes it possible to treat members as entities that can be assigned to variables and passed as parameters. So don't worry about this for now. We will examine each one of these in detail in the next videos, with examples, so you will have a better understanding of the concepts and their usage. So I'll see you in the next video. Let us now discuss further on the class types under the reference type. There are three types in the class types. The one is the object. This is the ultimate base class of all other types. For example, here we have defined a variable I as an integer equals 1, and then we define an object obj equals to I. So this means that we are doing a boxing, basically converting the value type into a reference type, which is the obj. Another type is the string, is a Unicode strings. An example here is just to declare string, variable name, and the value. And the third one is class. Class is a user-defined types of the form class, then class name, and then followed by open and close brackets. So here's the example. Let's say we define a class person. This is the open and close, and then we have here the public properties, the name and age. For the name we have the string data type, and for the age we have the integer data type, and both of them have the getter or setter, which means that the user can get the value of the name based on his instantiation of this person class, and he can also set the value of the name. Same with the age. This one here, this is called a constructor, which means that once the user initialize or instantiate a class person, and he can specify the name and the age, which will then be assigned to the public property name and age here. This one is the method called display name, which means that if the user calls this method based on the instantiated class object, then he will get this value in return. So let's say your name is whatever is the value that is specified in here. Your name is John or whatever. So that's how this class is being defined. So in the next video we will have some example of this. I'll see you there. Alright, so let us now create a project so we can see how classes works. Let me create a new project called class demo. Let's store this in the AutoCAD C# project folder, console application. In this project we are just going to create a very simple class, so you have a good understanding or grasp of it. But in the subsequent videos we will explore further and we will add more information to it. But in this demo it's just a very straightforward class demo. So we have here our main method. Let me create a new object called, a new class called person. So class person. So within this person class, let's have three properties. So to do that, just type in prop and then tab twice. So let's say this is the first name, Another property is last name. Another property is age. And we will create one public method, string display person info. And in this method, we are just going to concatenate the first name and last name and return it. So string full info equals full name is, then we concatenate the first name, provide some space, and then the last name, and also the age. And your age is, we concatenate the age here and make it to string because it's declared as integer. Then we return, because we specified here the return as a string, so we return the full info. So that is all for our class. Now how can we use that in our code, in our main program? So we need to instantiate the class person. Let's say we call this person equals new person, and then we can now supply the first name. Let's say Jen, person dot last name, let's say Kennedy, and then person dot age equals, let's say 28 years old. And now we can call the method display person info, and we can create a variable to store the return value. So string info equals person dot display person info, and then we just create a console dot write line the info, and then let's just have here console dot read line so we can see the results. So that is all. Very simple class, just to show you how to create properties and the public method, and how to use it in our program, how to instantiate, provide the needed information, and call the method to display the results. So let's see. There is an error. What's happening here? Oh, we forgot to provide a semicolon here. Try again. So full name is Jen Kennedy and your age is 28. This is exactly what we formatted here. Alright, so this is just a very simple class with a few methods, one method actually, and a few properties. We can actually create a constructor. So let's say we create a constructor called person, of course, with the following parameters. So string first name, string last name, int age. And then we can specify the first name equals the past first name, the last name equals this last name here, and age equals the age. So when we do that, oops, now it is complaining already. So in order for this to be not complaining, we can also create another constructor without any parameters. So public person, and that's it. So we have two constructors here, one without the parameters and the other one with the parameters. So let's say we create another instance, person, let's say p2 equals new person, but now we have two overloads here. I mean, yeah, two overloaded constructors. The first one is the blank, and the other one is with a string first name, last name, and age. So now we can provide here, let's say Jamie, last name is Oliver, and then age is, let's say 32, and then we can copy the same code here, but instead of person here, it should be p2, and we don't need to declare the info again, just use it, and that's it. So we should be seeing two instances of display in the console. One is using the constructor without the parameters, and the other one is using the constructor with parameters. So let's start and see how it goes. Yep, so the first one is full name is Jen Kennedy and your age is 28, and the other one is Jamie Oliver and your age is 32. Okay, so in this video we learned how to create our class, and we learned how to use them in our program. But let me just show you something, because the class person that we created is also within the same file as the program here. Alright, we can actually create a separate class on that. So let's right click here and add, and then we can select class. Just so let's call this as person and add that. Now we can copy this over, remove it from the main program file, and move it here. Replace this with this one. So now there's no more error here. So it's up to you to write the class if you want to create on its own file or from within the same program. I advise to do it this way if, let's say, you have a more complex code, but for demonstration purposes we can do just create from anywhere in this code here. So if we run again, it should give us the same results. Okay, so that's about it for the class type. I'll see you in the next video. Let us now examine further the interface type. So the interface is a user-defined types of the form interface I with the open and close bracket. So basically an interface is defined as a contract that all the classes inheriting the interface should follow. The interface defines the what part of the contract, and the deriving classes define the how part of the contract. So basically, interface contains only the declaration of the members. It is the responsibility of the deriving class to define the actual functionality of the members. So we will have an example of this in the next video. I'll see you there. Next on the reference types is array types. There are two types of array types. One is the single array, the other one is multidimensional array. In the single array, the declaration is something like, in this example we have the string array and followed by the var name. By the way, there is this open and close square bracket right after the type of the declaration, then the variable name, and then new string, and then open and close bracket. So in our example here, we have declared a single dimensional array for cars, which is new string followed by the values. Let's say we have here the Mustang, Chevy, and the Cadillac. So this is how you declare the single dimensional array. As for the multidimensional array, they have almost the same way of declaring, but the only difference is you have to specify the number of rows and columns in the after the data type, after the new instantiation. So in our example here, we have declared the cars 2D or cars 2-dimensional, but you notice the string followed by the open and close square bracket with a comma in the middle. So in here we have defined 3 rows with 2 columns. So basically, multi-dimensional array is an array of a single dimensional array. So in this case, we have defined Japan for Toyota, Korea for Hyundai, and US for Ford. So this is how you declare the multi-dimensional array. In the next video, we will have an example for this one, so you can better understand how it works. I'll see you in the next video. Okay, welcome to this demo. In this demo, we're going to explore array. I will show you how the array works. So in this video, we're going to just do the single dimensional array first. So let's call this project as arrays using the console.NET console application. Okay, so let's create a new method. Let's call this a single dim array exercise. Just hover over and then generate method. Okay, so first let's create a single dimensional array. So there are two ways to declare an array. The first one, let's have just an integer array for now. So integer, int, and then the open close square bracket, and then the variable name equals new integer and curly braces, and then you can specify the value here right away. Alright, so that is our array. Now let's say we wanted to extract all the items in the array and display it in the console window. We can write a for loop. Let's say for int I equals 0, and while I is less than the numbers that length, our variable here, the length means the length of the array, how many items do we have? So it's 5. Then every iteration we have to increment our I. Okay, and then all we have to do is console that right line, then the numbers and the index, which is I. So this I increments every loop until the I becomes equals to the length of our array, then it exits the loop. Okay, so let's just write here a read line so that our console window will not close right away. So this is basically the use of array. Declare like this, and then to extract the items inside the array, then just do a for loop and specify the index. Okay, let's give it a try. Save this one first and start. There you go. So we have here 2, 3, 5, 7, and 8. Okay. Another way to declare an array is, let's just comment out this line of code here, and then we do the same thing. Integer, and then open close square bracket, numbers equals new int, and then you can specify the length of the array right away, and then you can provide the value in each item in the array, or in each index. So let's say 1, and then just copy this over. Let's say the second element has a number, oops, this one first, 1, 2, 3, 4. So we have 5 here. Remember, in C# the arrays is 0 based, which means this is 0, 1, 2, 3, 4, 5. So same thing in here. Okay, so the second element, let's put there 4, and then 6 for the third item, and then 7 and 9. So this is another way of declaring an array. Okay, let's save it and run again. There you go, 1, 4, 6, 7, 9. So that's about it for the integer array. Okay, now for example, we would like to declare an array of string. So let me just comment out this code so that it won't execute again the next time we run it. And so this one here, let us declare an array of string. So same thing, the data type and the square bracket. Let's call our array as cars equals new string, then curly brackets, and then specify the value. Let's say Mustang. We have here the Chevy, and let's say Cadillac. Alright, so now we can loop into this array again. Say for int I equals 0, I is less than the cars that length I++, then console the right line, cars, and then the counter or the I. So exactly the same as this one here. The only difference is the string data type. So let us save our program and run the code again. There you go, Mustang, Chevy, and Cadillac. Okay, so same thing, we can do the same thing as this one here. Let me just comment out this line of code, and let's say cars equals new string. Let's say this one is 4. Then we can specify the cars equals, let's say the first one is, this is 0. Let's say we call this as Toyota. Let's just copy this over. Alright, so 0, 1, 2, 3, 4. Let's call this as Honda. Let's say BMW. We exceeded 1. We only have 4. Otherwise, the error will be array out of bounds. Porsche. Let's say. Alright, so these are the contents of our string array. Okay, let's give it a try. Save the code and start the program again. Toyota, Honda, BMW, and Porsche. So that's it for the array. Very simple, very easy to use. Okay, in the next video we're going to discuss the multidimensional array. I'll see you there. Alright, welcome to this demo. In this demo we're going to explore the multidimensional array. We will be building the method on top of the project that we have created earlier. So let's just comment out the first one here, and let's create a new method called multi-dim array exercise. Just hover over and then generate the method. Okay, so similar to the single dimensional array, we can declare the integer, but with the comma inside the square brackets, and then we specify our variable name. Let's say array2d equals new integer, comma, then the curly braces. So basically the multidimensional array is kind of array of single dimensional array. So in this case, let's say we have here the first row, the value is 1 and 2, okay, and the next array is 3 and 4. You can put space here, no problem. Let's make it consistent. Okay, much cleaner. And then the third element, or the third row, is, let's say, 5 and 6, and that will be our multidimensional array. So basically in this declaration here we have 3 rows with 2 columns. Okay, so there's the first row, there's the column 0 and column 1. There's the second row, column 0 and column 1. This is the third row, column 0 and column 1. Okay, so let's see the result if we extract all these elements using the, but this time we're going to use the for each loop. Okay, for each integer I in array2d, our variable here. We'll just do the console.write line, and then let's add some text here. Value is let's use the string formatter, and then put the I here. So basically this 0 here will be replaced by the I variable here. Okay, alright, let's save our program and let's start our code. Let's see. Oops, I forgot to put the read line here. Let's try again. Okay, so we have 1, 2, 3, 4, 5, 6, which means that the loop, our for each loop, go through or went through each of these elements in the array. Okay, so this is the first way of declaring a multi-dimensional array. Let me show you the other one. So same thing, we have to declare the integer with the comma inside the bracket. Call this array 2D equals new int. This time we'll put the dimension of the array. Okay, so this is exactly the same as the first one here, but now we can specify the array dimensions or the array locations. So this is the first one here. This is the first row, first column. This is the first row, second column. So let's copy that over. This now becomes row, first row, second column. So let's say this one has 2. Let me just copy this over. Okay, so the second row, first column here, this one will be 1 and this is 0. This is 1 and this is 1. This is 2 and this is 0. And this is 2 and this is 1. And 1, 2, 3, 4, 5, 6. So can you see the pattern here? This is the first row, first column, second column. This is the second row, first column, second column, and this is the third row, first column, second column. So if we look at the Excel equivalent, just to make it clear, we have here 3 rows, 1, 2, 3, which is this one here, and we have 2 columns, A and B. So the value is this one, 1 and 2, which is this one here, first row and first column, second column, 1, 2. And then second row, 3 and 4, first column, second column. Third row, 5 and 6, first column, second column. Okay, I hope that's already clear. So now let us run our code. There you go. So value is 1, 2, 3, 4, 5, 6. So that's about it for the integer array. Now let us try the string array. Let me just comment out that code there. Let's create our own array now, array of a string. Let's call this as cars 2D equals new string 3, 2, and then we can specify the array. Let's say for the cars, the country where the car is manufactured or made, let's say Japan, and we have here the Toyota, for example. Then the next array would be, let's say, Korea and Hyundai. Then let's say for the third row of our array is, let's say, US and Ford. Okay, so that is our array. Now if we loop into that array using the for each loop, we will be using the string here instead of I or integer. For each string s in cars 2D, we'll just do the same thing, console.writeLine, then value is, we have here the string formatter, and then s. Okay, so what do we expect here? It should show us Japan, Toyota, Korea, Hyundai, US, Ford. Let us save our project and start the program. Here you go, Japan, Toyota, Korea, Hyundai, US, Ford. Okay, so that's how it is. You declare or you extract the item in the array in a multi-dimensional array. Okay, I hope that is clear. If you see the equivalent in spreadsheet, it's something like this. So we have here Japan, Toyota, Korea, Hyundai, US, Ford. We have three rows and two columns. 1, 2, 3, and two columns, A and B. Okay? Alright, I'll see you in the next video. Let us now discuss about operators. In C# there are quite a number of operators as follows. The first one is we have the assignment operators. An assignment operator is the operator used to assign a new value to a variable, property, event, or indexer element. So this is basically just the equal sign that you assign a value to a certain variable. We have seen this in the previous lectures for the data types, where we assign some, let's say, integer variable to a certain value. So this is just the assignment operator. The next one is unary operators. This is an operator that takes one operand, such as the increment operator. That's why it's called the unary. There's just one operand. The next one is primary operators. These are the highest precedence operators. We will have this, by the way, all of these we will go through in more detail in the upcoming videos. The next is equality operators. The equality operator, or the double equal sign, returns true if the values of its operands are equal. Otherwise, it returns false. Additive operators. These are the operators that are used to add or subtract values. So it's just a plus and a minus sign actually. Multiplicative operators. These are the operators that are used to perform multiplication, division, and remainder. Relational and type operators. These are the operators that are used to check the relation between two operands to determine whether the values are equal or not. The last type of operator is the logical, conditional, and null operators. These are the operators that are used to perform the logical operation between two operands. So, as mentioned earlier, we are going to have a more detailed discussion on each of these operators. So I'll see you there. Let us now discuss about the assignment operators. So there are quite some variations of the assignment operators. The simplest one is just a single equal sign. Basically just to assign a certain variable with a certain value. For example, we have here the integer x equals 2, or string str equals double quote hello double quote. However, the compound assignment is a mixture of the equal sign plus the arithmetic signs. Like for example, x plus equal sign equals y. This basically means that you have to add the value of x and y, then assign the results into the variable x. So in this example, we have x equals 2 and y equals 1. So if we execute the expression x plus equals y, the resulting value of x, the variable x, will be 3. So the next one is x minus equals y. This is the opposite of the x plus equals y, so which means that the new value of x will be the result of x minus y. So for example, we have here the integer x equals 2 and the integer equals y equals 1. So the result would be of the x would be x minus equals y is 1. So basically x minus y 1, and then just assign the result to variable x. Same thing with the x asterisk or multiply equals y. So instead of adding or subtracting, it's basically multiplying the value of x and y, then assign it to the variable x. So if we have here x equals 2 and y equals 3, if we execute this expression x multiply equals y, the resulting value of x would be 6. And the last compound assignment is x and forward slash or divide equals y. So this is basically a division expression, and assign the resulting value into the variable x. So in our example here, we have x equals 8 and the y equals 2. By executing this expression, x divide equals y, and assigning the resulting value to x, the value would be 4. In the next video, we're going to have a demo so that you will have a better understanding of all these assignment operators. I'll see you there. Welcome to this demo. In this demo, we're going to see how the assignment operators works. So let's get started and create a new project. Let's call this as console.NET application, and let's call this as operators. Okay. Alright, so this is our project here. This is the boilerplate. The Visual Studio provides the program.cs by default. These are all the libraries, different libraries that is being provided also by IDE, but we don't necessarily need all of this except probably the system, but we'll just leave it for now. So let's get started with creating a new method called assignment operators. Just hover over the method name and click on this symbol here and generate method. It will generate the method for us. Okay, so let's start with assigning the value of x equals 2 as in the slide presentation. So just that's it, by assigning number 2 into the variable x. And console.writeLine x, and we should see that 2. Let me just provide here a console.readLine or read key so that we can see the output. Otherwise the program will run and then it will close automatically. By the way, if you are wondering what the console is, it's just basically the command prompt. If you type in here cmd, so this is the console in the .NET. It's just the Windows command prompt. Okay. Alright, so let's run this program and see the output. There you go. We have here the 2. Okay. So that's just about the regarding the assignment operator. Next, let's see how the plus and equal expression behaves. So let me comment out this one here. We'll create another variable equals y equals 1, for example, and then console.write line x plus equals y, and let's see what's the output. So we should expect here the result would be 3. There you go, 3. Okay. Now let's do the same thing for the minus. Let's comment out this one here and basically use the minus one here, minus equals. So basically this one interprets as x minus y, and that would be the value of x. So in this case we should be expecting a 1. Yep, there it is. Next, let's say we create another variable. We change the variable of y to 3, and then we'll do the console.write line x multiplication equals y. So the result here would be 6. We declare the y here, but we override the value with 3 instead of 1. So now the y has a number 3 value. Let's run this. We have 6. Okay. Next, let's say I change the value of x to 8 and y equals 2. Then if I console.write line use the divide equals, we should be getting 4. Let's give this a try. There you go, we have the 4. Alright, so that's just how simple it is to use the assignment operators, both the simplest form and the compound assignment, and you get the result as expected. Okay, in the next video we're going to have a demo on unary operators. I'll see you there. Let us now discuss the unary operators. So by definition, it is an operator that takes one operand, such as the increment operator or the decrement operator. So the first one here is, it's called a pre-increment operator, which means that, for example, we have here x equals to 0, and if we execute this expression plus x, the value of x now will be equals to 1. It's just increment the existing value of the variable. If let's say x equals 10, for example, as its current value, and you execute plus x, the value of x will become 11. It's just increment by 1. The next one is the pre-decrement operator. So instead of plus, you use minus x. So in our example here, we have int x equals 5, and if we execute the pre-decrement operator, the value of x will now be equals 4. So it reduces by 1. It decrements by 1. These are very useful in doing some looping, where you have certain amount of your number of loops that you want to execute based on the counter. So you can use either one of these two. In the next video we will have a demo, so you see how this pre-increment and pre-decrement works. I'll see you there. Welcome to this demo. In this demo, I will show you how the Unary operator works. So let's get started. Let's create a new function called Unary operators. Okay, let's just hover over the symbol here and generate the method for us. Alright, so let's create a new variable of integer type. Let's say x equals to 0. And we examine the value if we do the pre-increment. We just create the console.readline here so we can see the output. So we should be expecting a value of 1 because it will increment the x with 1. So let's give it a try. There you go, we have 1. Next, if we use the pre-increment, if we use the pre-decrement, I mean, let's comment out this code here. Before that, let me just assign a new value to x. Let's say 5, and we run this code with the pre-decrement operator. We should be expecting a value of 4. Yeah. So that's about it for the Unary operators. In the next video, we're going to examine the primary operators. I'll see you there. Let us now discuss the primary operators. By definition, primary operators, these are the highest precedence operators. So we have here 4 different types of primary operators. The first one is the member access. So for example, we have an object X and we would like to access the property Y. All we have to do is put the dot and you can see the properties, or you can retrieve the value of the properties. For example, we have an object line or ln as a new line. Now we can assign the color index value to it by just putting the dot expression. So that's just as straightforward it is. The next one is the array and indexer access. So this is the expression a and then bracket x. This is basically the number of the element in the array. So for example, we have here an array of fruits, which is a string, and we have a value of 2. Let's say for the first element we assign the value apple, and the second element of the array is mango. Now if we retrieve the value of the array variable and assign it to our, let's say, fruit string, so we have here the value. So basically whatever the index you put in the array, you can retrieve the value or assign a value to it. The next one is x++. This is a post increment operator. For example, we have an integer x equals to 0 and we execute this expression. It just increment by 1. And the last primary operator is x-, which is a post decrement operator. So if we have, let's say, x equals 5, then we execute the x minus expression. The value of our x now will be 4. It just decrements by 1. Okay, so in the next video we will have a demo of all these primary operators. I'll see you there. Welcome to this demo. In this demo we are going to discuss the primary operators. So we have here 4 examples as shown on the slide. The first one is the member access, second one is array and indexer access, and the third is the post increment, and the last one is the post decrement. So let's start with the member access. Let me just quickly create a new class called line, and then we'll set a new property, let's say color index. By the way, we will discuss further on creating classes when we reach the object-oriented section of the course. So for now, just follow along. So now we have this object called line, and we have one property of the object called color index. Now we can instantiate a class, and we can assign it to an object. So basically, line, let's say ln equals new line, and now ln dot, okay, see this one, the properties. So that's just how easy it is to access the properties or methods of the object. Now we can assign a value of 1, for example. So that's just about it for the member access. Now let's go to the next one, the array and indexer access. So let me create an array of string, let's say as shown in the slide, array of string fruits, and it has a value of 2. So the fruits 0, the first element in the array has the value of apple, and the second element has the value of mango. And then if we create a new string variable, fab fruits equals the fruits and the first element, or the second element, for example. Then if we see the results, let's say my favorite fruit is fab fruit, okay? That read line. Just put this one at the bottom. Alright, so let's run this code. My favorite fruit is mango, as in the second value of the second element of the array. Alright, that's about it for the array and indexer access. All you have to do is specify the length of the array and the index, and you should see the correct value. Now let's go to the post increment. Let me create a new variable called x, integer x with the value of 3, and then if I console that write line, value of x is post increment. Let's do the same thing for the, let's now examine the value of x after we incremented it. So the first one is we initialize the value of x to 3, and then we print the value of x plus plus, and then we check the value of x again. So let's see the results. Alright, initially the value of x is assigned a 3, then we post increment, which means that when we retrieve the value of x here, it's still a 3 because it's a post, it's not pre-increment, unlike the previous example we have from the Unary demo. If it's a pre-increment, it will increment the value of x right away, but in this case it's a post-increment. So it will just assign it will increment the value of x and assign it to x. That's why when we printed the value of x here, it becomes 4 already. Okay. Next, let's see how the post decrement work. Let's create a new variable y equals 5, and then let's just copy over these 2 lines of codes here. The value of y is y and then minus minus post decrement. Okay, so let me comment out this code and run the program. So we should see here, initially we have a value of y to 5, and it's still the same value when we extract the value here because it's post decrement. Now when we examine the value after it has been post decremented, the value becomes 4. Okay, so that's about it for the primary operators. I'll see you in the next video. Let us now discuss the equality operators. So by definition, the equality operators return true if the values of its operands are equal. Otherwise, it returns false. So the first expression we have here is the equal expression, which is the double equal sign. For example, we have the x equals 2 and y equals 2. If we do the comparison, is x equals y, then the result will be true because both of them have the same values. So the next operator is the not equal, which is the punctuation mark here, or the bang sign, and the equal sign. So is x not equal to y? So in this example, we have x equals 2 and y equals 2. Is x not equals to y? The result is false because they are equal. So that's just as straightforward it is. So in the next video, we will also have a demo of these equality operators. I'll see you there. Welcome to this demo. In this demo, we're going to see how the equality operators work. We have the double equals and the not equal, the punctuation mark and the equal sign. So I have here created the method and initialized 2 variables, x and y, both integers, and has a value of 2. So if we now apply the equality operators, if x equals y, then let's say that console.writeLine, x is equal to y. Alright, so let's just give this a try. We should see this message here. Yep. Next, let's see the not equal operator, how it works. So let me just change the value of y to 3. So now if we validate, if x is not equal to y, then we just print a message here, x is not equal to y. Okay, so this is the equal sign, this is the not equal sign. Let me just run the code. There you go. So that's about it for the equality operators. The double equal sign is used to compare if they are equal, and the punctuation and the equal sign used to compare if they are not equal. So depending on how your logic works, you can insert here the appropriate code to be processed accordingly. Alright, that's it for the equality operators. I'll see you in the next video. Okay, next let's discuss the additive operators. So by definition, these are the operators that used to add or subtract values. However, there is also an additional functionality for the plus sign. In the case of string, it concatenates or combines the two strings. So the first one here is x plus y. In terms of the integer values, it just basically adds those values, and we have here the results. For the string concatenation, if we have two variables holding both the string, and then we use the plus sign on those variables, it just basically combines those two strings. The next one is the subtraction. So as simple it is, it's just subtract from the first operand by the second operand, and we have here the results. If we have x equals 5 and y equals 2, x minus y just equals 3. That's just how simple it is. In the next video, we will also have a demo for these operators. I'll see you there. Welcome to this additive operators demo. So I have already created the method called additive operators, and in here I created two variables, both integer, x equals 2 and y equals 3, and then we examine the code if we add those two values using the plus, and we have here the minus. These are both the two additive operators. However, for the plus, we also use that to concatenate the strings or combine the string into a one full string. So in this case, we have the s1 variable called with a value of hello and s2 world. When we concatenate those two strings, we should get the hello world results. And then in here, I changed the value to the value of x to 5, and we subtracted x minus y. So we should see 5 hello world and 2. Let's run the code. Yep, there you go. So we have the first one, the addition, we have the concatenation, and we have the subtraction. So that's about it for the additive operators. Let us now discuss the multiplicative operators. So there are just three expressions for the multiplicative operators. The first one is multiplication, which is just multiply the operands and get the results. The other one is the division, which is the /, and it's just divides the two operands. The third one is the remainder, or the modulo operator. So in this example here, we have 10, then the modulo 3, and we have the remainder 1. So these are just the three operators, multiplicative operators. We also have a demo after this video, so I'll see you there. Welcome to this multiplicative operators demo. I have already created the method here, and we don't need to initialize a variable just to see the results. We can just actually provide the numbers that we want to see. So on the slide we have these 2 times 5, we should get 10, and 12 divided by 4 using the division operator, and then the remainder. So basically 10 and then divide or modulo by 3, and then we should get the remainder of 1. So let's run the code. Yep. So the first one is just multiply 2 by 5, we have 10, and divide 12 by 4 on the second line, and then get the remainder on the third line. 10 modulo 3, we get the remainder of 1. So that's about it for the multiplicative operators. Very straightforward, very easy to understand. I'll see you in the next video. In this lecture, we're going to discuss the relational and type operators. So what are relational and type operators? By definition, these are the operators that are used to check the relation between two operands to determine whether the values are equal or not. So the first expression we have here is the less than. So it's just compare these two operands, x and y, if x is less than y. And it returns true if the expression or the result is true. Otherwise, it returns false. So in this case, 2 is less than 3, so the result is true. Next, the greater than, this expression here. So x is greater than y. So in our example here, is 2 greater than 3? Of course, it's false. The next one here is less than or equal. Is the value of x less than or equal to y? In our example here, x is less than or equal to 3. The result is true. It may be less than, but it is equal. So either of these two expressions satisfies the condition, then the result will be true. Next, the greater than or equal. Same as the less than or equal, it's just evaluates the first operand to the second. Either it is greater than or equal to the second operand. So in our case here, is 2 greater than 3? No, it's false. Is 2 equal to 3? It's also false. So it returns false. Next, the is expression. It says here, return true if x is a certain type, t. It returns false otherwise. So in our example here, let's say we have an object line and we assign it to x, and then we execute this expression. Is the value of x is line? Yes, it is. So the result is true. Next expression is the as. Basically assigning the x variable as the type t or the t. So it returned the type of x as t. Whatever object is t that you cast it or assign it to x. Otherwise, it return null if x is not a t or not as a particular type. In our example here, we have line. We make x as a line object. So x as line, so it results as line. So basically we make x as a line object. We'll see all of this in action in our demo in the next video. I'll see you there. Finally, we've come to the last part of the operators. We have the logical, conditional, and null operators. The first one we have here is the logical AND, and it has this expression x ampersand y, which means that it's a Boolean logical AND. So the expression x ampersand y is true if both x and y are true. Otherwise, it's false. The next one we have here is the logical XOR or exclusive OR with the symbol of the arrow pointing upwards. So that is the Boolean logical XOR. For bool operands, the logical XOR symbol computes the logical exclusive OR of its operands. That is, the result is true if and only if exactly one of its operands is true. Next, we have here the logical OR with a symbol of a single pipe. So it's a Boolean logical OR. So for bool operands, the logical OR, the symbol pipe, computes the logical OR of its operands. That is, the result is false if and only if both its operands are false. The next one is conditional AND with a symbol of a double ampersand. So it evaluates Y only if X is true. So basically it results to true if both X and Y are true. The next one is conditional OR with a symbol of a double pipe. So it evaluates Y only if X is false. So the result will be true if either X or Y is true. Next, the null coalescing. It has a symbol of two question marks. So X double question mark Y. It evaluates to Y if X is null. Otherwise, it evaluates to X. And the last one is the conditional, which has only a single question mark and a colon. So basically, it evaluates to Y if X is true. Otherwise, it evaluates to Z if X is false. So we will see all this in our actual demo in the next video. I'll see you there. Welcome to this demo. In this demo, we're going to examine the logical, conditional, and null operators. So I have here created a new method already, logical, conditional, and null operators, and provided some code. So we have the logical AND, we have the logical XOR or exclusive OR, we have the logical OR, we have the conditional AND, we have the conditional OR, and we have the null coalescing operator and the conditional operator. So let's go through them one by one. Let's start with the logical AND operators. So this is our expression here. So by definition, the Boolean logical AND, if X and Y are true, then it will return true. Otherwise, if either of these two is false, then it will return false. So let's run this code. So we should be expecting true because both X and Y are true. Yeah, there it is. So if we change this value to false, now X is true, Y is false, we should be expecting a false results. Yep. Okay, so now let me comment out this code and uncomment this part here. You can use this function here to uncomment, to comment, and this one to uncomment. It's useful when you're doing commenting a block of code. Alright, so let's examine the exclusive OR. By definition, for bool operands, the exclusive OR computes the logical exclusive OR of its operands. That is, the result is true if and only if exactly one of its operands is true. So in this case, I have assigned here the false and x is true. What will then be the result of this? It should return to true because one of its operand is true. Exactly one of its operand is true. That's the definition. So let's give it a try. Yep. That's how the logical exclusive OR works. Let me now comment out this particular code and let's go through the logical OR. By definition, for bool operands, this symbol, the pipe symbol, computes the logical OR of its operands. That is, the result is false if and only if both its operands are false. Which means that we have here the x is true and the y is false. This will still return true because it will only return false if both the operands are false. So let's give this a try. Yep. Okay, moving on. Let's now examine the conditional AND operator. So this one, the result is true if both x and y are true. So in this case, we still have a value of true for x, and also now we assign true back to the y variable. So since they are both true, this line of code will be executed. Let's give it a try. Yep, there you go. Next, let's move on to the conditional OR. So I change back the value of y to false and leave the x to true. But this one here, regardless of y or x is true, either one is true, then it will return true. Let's run the program. There you go. Comment out here and let's try the null coalescing operator. So by definition, the null coalescing operator means it evaluates to y if the x is null. In our slide, it shows something like x double question mark y. So it says it evaluates to y if x is null. Okay, so in this case, y is 5 and we assign the I to null. So it should give us 5 here. Run it. Yep, there you go. Okay, so going to the last operator here. Let me uncomment this. The definition is it evaluates to y if x is true, z if x is false. So the slide shows something like x question mark y then colon z. Okay, so it evaluates to y if x is true, otherwise it evaluates to z. So in this case, our x is the counter equals 2, but I assign here 1, which means that the x is false, so it should evaluate now to z. So it should display hi instead of hello. But if we change this to 2, it should display to hello. So we should be expecting a hi instead of hello here. Let's run it. Yep, there you go. So that's about it for the conditional, logical, and null operators. I'll see you in the next video. Our next topic is conditionals. There are two types of conditionals in C#. The first one is the if-else conditional, and the other one is switch. The if-else is basically an if statement identifies which statement to run based on the value of a Boolean expression. We will have a demo of these two in the next video so that it will be clear for you to understand the behavior of each of these two conditionals. For the switch is a selection statement that chooses a single switch section to execute from a list of candidates based on a pattern match with the match expression. So we will see both of these two in our next video on how they are being structured and how they work in the program. I'll see you there. Just before our demo, let me just show you the structure of if, else if, and else. So the first one here is just the if condition. If, let's say, there is no false expression that you are considering, there's no logic for the false results, so you can just use the if. So basically, if true, then do something here, and that's it. In this second column here, we have the else statement, which means that if the condition is false, then we have to execute the else part of the code block. So in this case, if condition is true, then we are doing the then statement here. Otherwise, if this condition is false, then it will execute this code block here, the else statement. However, sometimes in our program, there are many different scenarios that you want to catch. So in this third column here, we have the if, else if, and else. This can go on as many conditions you have as possible. So this is just the simple application of if, then else if, and else. Basically, if the first condition is true, then it will execute this code block here. Otherwise, if this is false and you want to evaluate another expression, then if this condition here is true, this code block will be executed, the else if statement code block. Otherwise, if this is false, then it will now go to the else statement code block here. So those are the three different if, else if, and else code structure. So in the next video, we will see all this in action. I'll see you there. Welcome to this demo. This demo is all about conditionals we've learned in the previous video. I have created here a new project called Conditionals, and we will go over the if else, and if else if exercises, as well as the switch exercise. So let's start with the if statement exercise without the else. So we have here the method if exercise is the one here. I just created another method called get random number. So basically, just to give us a random number from the range that we specify. So for example, we specify the minimum of 9 and maximum of 15. It will just give us the number from 9 to 15 in random. So basically just to try to satisfy this condition here. So in this method, I have created a variable CTR or counter with a value of 10, and we get the random number and store it in the num variable based on this range. So if the number is greater than the counter, let's say the number returned is 11 or 12, then this statement here will be executed. Okay, so let's give this a try. Yep, so the number 11 is greater than the counter, which means that this is true. When we get the random number, it gave us 11, so this was executed. Okay, so that's all for the if statement without the else statement. Next, let's do the if else exercise, which means that we have the if and the else statement here. So same logic, I just basically reduce the minimum range from 7 and the maximum is still 15, and we will see if the number that's generated is less than the counter, then the else statement should be executed. Okay, by the way, just to point out to you that you might notice this bracket 0, and we have here the parameter called num. So this is basically a format specification in the console.writeline method, which means that the first entity, I mean the first object that's specified in here, the first number, will be the first parameter here. So if we have another something like that, and we have here, for example, num2, something like that, so it will execute the num in the num2. Okay, just to point it out to you. But other than that, that's just basically to make it more flexible, I should say. Okay, so let's now run this project. Okay, so the number we've got is 9, which means the else statement is was executed. Okay, if we try it again, the number 10 is less than the counter. See this one here? Our counter is 10 and the return number is 10, but our condition is the number greater than the counter. It's not greater, it's equal. So this one in turn is still translate to false. That's why it still execute the else statement. Okay, next let's try the if exercise, which means that we have 3 occurrences of the if statement, I mean 2 and the else. So same logic, we just get the number and then compare the values of the returned random number. In this case, I just narrowed down the range, so at least we have a high probability that we can hit either 11 or either 10, where we put here the equals. If not, it will execute the else statement here. So let's run this program. Yep, so the number 10 is equal counter, which means that it executes the second else if here. Okay, wherein in the previous example here it returns 10, but since we did not handle this particular condition, the equal condition, so it went into the else statement. Alright, so let's give this another run. Now number 9 is less than the counter, which means that this line of code was executed. Okay, so that's about it for the if else if exercise. I'll see you in the next video. Just before going into the switch statement demo, let me just show you how the switch structure is being presented. So in this table here we have two columns. The first one is the case statement, or the switch statement has two cases plus the default value, and on the right column we have the n cases, which means that it could be more than 2 or as many as your program requires, plus the default option. So the structure of switch statement is basically switch and the value that you want to evaluate here. In our case, we have declared the case switch as an integer with the value of 1. Then this is how the switch statement is being structured. So case 1, which means this particular code will be executed because it already satisfied the value that we are evaluating here. However, let's say this case switch equals 2, then this case will be executed. If this value is 3, then it will go to the default, which means that none of these two cases satisfied our value of the case switch. So this default case will be executed. And each of the case has a break, which means that once I'm done executing this code, then I will exit the switch statement already and proceed with the next line of code below this. In the next case here we have n cases, which means that case n, this could be up to how many as your program requires. So in our case here we have a case switch equals 1. Then when we run this code block, it will also satisfy this condition here, and then write the value to the console and exit the loop. Otherwise, if this is something else, then the case n, maybe case 3, case 4, case 5, and so on and so forth. So that is how the case statement works. Okay, so in the next video we will see all this in our example. I'll see you there. Welcome to this demo about the switch statement. So let's just continue working on the earlier project that we had for the if-else exercise. So I have here created another method called switch exercise, and this is our code. So in here I just declare a string variable of fruit, and we are prompting the user to enter the preferred fruit, and then we capture the value into our fruit variable, and we convert it to lower, which means that whatever they type, capital or small caps, it will always be converted to lower, and then we handle it using the case statement here. Okay, so this is how the switch structure works, as we've seen from the previous video. So I also wrap this code into a while loop so that we can enter as many times as we want, so we can see each of these cases to be executed. So while fruit is not equal to x, we specify here x to exit. So if they type x, then we will exit the code. Otherwise, it will keep prompting of your fruit preference. And then whatever they selected here, we display it using the console.write, and then ask them again. So it's just basically keep on looping until the user provided the x, and then we message here bye. Okay, so let's give this a try. Enter your fruit preference. Let's say mango. You like mango, which means that this is the code that has been executed. Next, let's enter another fruit. Let's say apple. Apple is your first choice, which is this one here. Alright, let's try another one. Let's say orange. You preferred orange. So this is how the switch statement works. There is always a case, so depending on the value of your switch expression here, it will be evaluated, and then it will execute this specific code block, then break the loop, exit the switch statement, and it just keep going on and on. So however, we have here a default, which means that if none of these three cases were satisfied, then it will go into the default value. So let's say we put grape. Nope, you are having a banana today. Alright, so until we type in x, and it says bye. Alright, so that's how the switch statement works. I hope this is clear enough, and you can give it a try. It's easy to understand. It's quite straightforward to follow. Just make sure that your switch statement is clear and you can handle it in different cases here. Okay, I'll see you in the next video. Welcome to this lecture. In this lecture, we're going to discuss about loops in C#. So, what are loops for? Why do you need loops? For example, in AutoCAD drawing, if let's say we have a number of blocks and we want to process each one of them, so we have to do a loop so that we can examine each of the object that we are processing and maybe extract those attributes or information. So basically, looping is processing a repetitive task, or maybe processing a certain number of times for your requirement, for example. And in C# there are 4 ways to do that. We have the for loop, we have the Foreach loop, we have the while loop, and the do while loop. So in this lecture, we'll just go over the high level of each, but in the subsequent videos, we will examine each one of them in more detail and how are they structured. So for the for loop, the for statement executes a statement or a block of statements, while a specified Boolean expression evaluates to true. The next one is the for each loop. The for each statement executes a statement or a block of statements for each element in an instance of the type that implements the system.collections.IEnumerable, or system.collections.generic IEnumerableT interface. Basically, the for each loop is mainly used in the objects. If you have different objects in a collection and you want to process each of those objects, so you use the for each loop. And the while loop, it executes a statement or a block of statements while a specified Boolean expression evaluates to true. So while it's true, keep going, because that expression is evaluated before each execution of the loop. A while loop executes 0 or more times. This differs from the do loop, the do while loop, which executes 1 or more times. Next, the do while loop. It executes a statement or a block of statements while a specified Boolean expression evaluates to true. Because that expression is evaluated after each execution of the loop, a do while loop executes 1 or more times. This differs from the while loop, which executes 0 or more times. And I have here a note that at any point within the loop's statement block, you can break out of the loop by using the break statement. So this break statement is common to all of these loop. Alright, so in the next upcoming videos, we will be examining each one of these loop structures in more detail. I'll see you in the next video. Let us now examine the for loop in more detail. So the structure of the for loop is this. We have the for, then the open close parenthesis, and we have the initializer, the condition, and the iterator. So the initializer basically is executed only once before entering the loop. So it's just initializing the value of basically the counter that you're going to use in the loop. Then the condition, it must be a Boolean expression. The expression is evaluated before every loop iteration, which means that if it's still valid or if it's still true, the loop just keeps going. And the next is the third part of the for structure is the iterator. It defines what happens after each iteration of the loop, of the body of the loop. So in this example here, we have the for, and then we have the integer I initialized to 0. Then we have the condition. Basically, I is less than 10. For as long as I is less than 10, we keep doing this stuff. And the third part of the for structure is the increment operator. Basically, this is the post increment, which means that every single pass we increment the value of I until the I is equal to the condition here, the value. So if the value of I is already 10, this condition translates to false, then that exits the loop. So in the next video, we will have an actual demo for this, so you can understand better. I'll see you there. Welcome to this demo. In this demo, we will be using all the different looping structures. So I have created here a project called loops. So in this video, we will be trying the for loop exercise. So there is a method here, for loop exercise. And as discussed in the previous video, the for loop is basically having three components: the initializer, and then the condition, and the iterator. So in this example here, basically we're just looping 10 times or 11 times because we're starting from 0. So we initialize our I to 0, then our condition, while it's less than or equal to 10, then we increment it. And for every pass, we will be writing the value of I, concatenating it with this text here. Okay, so let's run this code and see the output. Alright, so the first pass, the value of I is 0. Then the next pass, it gets incremented, becomes 1, and so on, and until 10. Because our condition is less than or equal. That's why 10 is still gets processed. Alright, so that's just how straightforward it is for the for loop. In the next exercise, we will examine the for each loop. I'll see you there. For each loop, let us now examine the structure of the for each loop. So we have here the for each, then the object type obj variable in the object collection, and then we do something here. So we have two parts or component of the for each loop. One is the object type. It basically defines the type of object in the collection. And the other one is the object collection. That is the collection of objects to be iterated from. So we have here the example. Let's say we have a collection of line objects stored in a line collection variable. We can loop through each of the line objects from within this collection by using this syntax. The object type should be line, and we just specify the variable of the object here. You can rename it any name you want, because this will be the name that you will be needing to retrieve the properties or methods of that particular object. So in this case, we can change the layer, for example, set it to wall, and you can do many other stuff in here. Okay, so this is very straightforward. Just make sure that you know the object type that you are iterating from, so you can specify the proper object type here. Okay, in the next video we will have a demo of the for each loop. I'll see you there. Welcome to this demo. In this demo we are going to use the for each loop in our exercise. So I have here a method called for each loop exercise, and I have also created a class called myCircle so that we can create an instance of this class into maybe 3 or 4 objects, and we will add them into the collection, and then we will use the for each loop to extract the information of each of those objects. Okay, so in our code we use the myCircle object and instantiate MC1 as one of the object as new myCircle. Then we can specify the ID here, the color, and the radius. Okay, so I have already pre-populated all of these attributes, all of these properties. The first one with the ID of 1, 2, 3, color is red, radius is 1. The next circle is having an ID of 3, 4, 5, color is blue, and radius is 2. and MC3, 6, 7, 8, green, and 3. Now we have this list of my circle collection. So basically we have a list that will store all of our objects, the instance of our MyCircle objects. So just declare it and specify the type of the object that you are going to be storing, and then add the objects accordingly. Okay, now here comes the for each loop. So as shown in the previous slide, we have here the object type, which is this one here, then the name or the variable name, and the collection is MCS. It's here defined in our list of MyCircle collection. Okay, so each of these paths we will be basically retrieving the information of the circle and just writing it to the console. We have here the ID, which is the value of the ID, and convert it to string because this is integer, and we are concatenating with the ID here, so it should be to string. And the color is already in string data type, so we don't need to convert it to string. Radius, it's in the integer data type, that's why we also needed to convert to string here. So that's just basically what the for each is doing. We loop through the collection of objects, then we can do whatever we want. In our case here, we're just displaying it to the console. So let's give this a try. Yep, so the first one, we have here the ID 123, color is red and radius is 1. Second circle is blue with the 345 ID and the radius is 2. And the third circle has the 678 ID, green color, and radius is 3. So that's about it for the for each loop. Very straightforward, easy to use. Just basically declare your object type and specify the object name in the collection, and do whatever you want for the properties or the information. Alright, I'll see you in the next video. Let us now examine the structure of while loop. So we have here while condition enclosed in the parentheses. While n is less than the limit, you do the processing here, and then you increment the value of n, which means that for as long as this condition is valid, for as long as the n is less than the limit, it keeps doing it. But when it reaches the limit, let's say n is now equals the limit, then the loop exits. Okay, so the n is basically the value that gets incremented every iteration, and the limit is the maximum value that the n can reach before exiting the loop. So in our example here, we have defined two variables. One is n and the other one is limit, both integer. You can declare this type of declaration of variables for as long as they have the same data type, just separate by comma. Now we do our while loop. So the first pass, n is 0 and limit is 5, which means 0 is less than 5, so we execute this statement here, and then we increment the value of n. So it keeps going until n reaches 5, which means while 5 is less than 5, which is already false because they are now equal, then the while loop will exit. So in the next video we will have a demo of the while. so that you have a better understanding of how it works. I'll see you there. Welcome to this demo. In this demo we'll be using the while loop. So we have here the function called while loop, or the method while loop exercise. So in here we have one variable called CTR, or counter, as an integer, and here's the condition in the while loop. So while counter is less than or equal to 10, do this code block here and then increment the counter. Okay, so this loop will be running for 10 times, starting from 1 to 9 basically. So 9 times actually, or 10, because our condition is less than or equal. So even though the value is already 10, then it will still execute one more time. Alright, so let's give this a try. Yep, as expected, we have here the value of counter is 1. That's the first pass, first run. Then we increment, counter becomes 2, and then becomes 3, and so on until the value is 10, which is equal or less than 10. And after that, it exits the loop. So that's about it for the while loop. Very simple, very straightforward. And I'll see you in the next video. And lastly, we have the do while loop. So what does the do while loop do? It executes a statement or a block of statements while a specified Boolean expression evaluates to true. Because that expression is evaluated after each execution of the loop, a do while loop executes one or more times. This differs from the while loop, which executes 0 or more times. So in this case here we have the structure of do while loop. Let's for example, we have initialized n as an integer variable, initialize it to 0, and we have here the limit also. However, the evaluation of the condition is after performing first a certain process and then incrementing the n. That's why it executes one or more. There's always a chance that this block of code here will be executed prior to evaluating if it's still valid when it's already reached the limit. So we have here the variable called n. This is the value that gets incremented every iteration. And we have the limit, that is the maximum value that the n can reach before exiting the loop. So in our example here we have n equals 0 and limit equals 5. So we do the do while loop, do, process this statement, increment, then evaluate. So in this case, for as long as the n is less than the limit, it will keep performing this block of code. Okay, so in the next video we will have a demo of this do while loop so we can understand better. I'll see you there. Welcome to this demo. In this demo we're going to try the do while loop. So we have here the method called do while loop exercise. It's being called from the main. So we have here a counter called CTR with a data type of integer initialized to 0. And here's our do while structure. So the first run, it will perform this code right away, and then it will increment the counter. Then we evaluate the counter. So that's why the do while loop always has a one or more execution times, because this is always be executed even prior to us evaluating the condition, whether it's still valid or not, or true or false. Okay, so that's just about it. We write the value of I, we increment the counter, and then we evaluate if the counter is still valid, which is less than 10, which means that this will execute 10 times, because this condition will have a 9 times, 9 iterations, plus the one that executes on the first pass. So let's run this code. Yeah, so it starts with 0, 1, 2, 3 until 9, which means that it executes 10 times. Okay, so that's about the do while loop structure. So when you're doing your program, your code, you might want to choose which is the best option for you to use in your looping. You can use the for loop, you can use the do while loop, or the do or the while loop. And if you are looping through the objects, use the for each loop. Alright, so that concludes our discussion on loops, and I'll see you in the next video. Welcome to this lecture. In this lecture, we're going to discuss about keywords in C#, or sometimes called as reserved words. So keywords are predefined reserved identifiers that have special meanings to the compiler. They cannot be used as identifiers in your program. So we have different categories here for the keywords, and these are the keywords for each category. In the type category, we have here the void, var, bool, byte, char, decimal, and most of the signed and unsigned integers, and also classes, delegate, dynamic, interface, object, and string. For the modifiers, we have here the abstract, async, const, event, extern, and so many other keywords. For the statement, we have the if and else, we have the switch, we have the do, for each, while, break, continue, and so many others like try catch, try finally, and uncheck, fixed, lock. For the method parameters, we have the params, in, ref, and out. For the namespace keywords, we have the namespace, using, extern alias. For the operator, we have as, await, is, new, and these other operator keywords. For the conversion, we have the explicit, implicit, and the operator. For the access, we have the base and these keywords. Literal, we have the null and default. For the contextual, we have the add, get, global, partial, and all this. For the query, we have the from, where, select, group, and all these keywords here. So basically the takeaway is that you cannot use this in your code. There is a way that you can use this, but it's not advisable. You can actually prefix by any of these keywords with the @ sign, and you can use it, but I'd rather not recommend doing that. So these are just the keywords for your information. if you are developing your program, try as much as possible avoid any one of these. Basically, the compiler will already complain once you use one of these as your variable. But as I mentioned earlier, there is a workaround if you really want to use it by just putting an @ sign as a prefix for any of these keywords. But I would not recommend using that. So that's it for the keywords. I'll see you in the next video. Welcome back. In this lecture, we're going to discuss what debugging is. So what is debugging in the program? What does that mean? It is the process of trying to track down errors in the program. What are the type of errors, you might ask? So when you are coding, there are 3 types of errors that you are going to encounter. The more you code, the more the chances that you encounter some errors. So let us define what are those errors. The first one is design time errors. These are the errors that happen during development. This is the least of our worry, because with the IntelliSense of Visual Studio, the chances of having a design time error is very slim, or I mean it's easy to spot. It's easy to see because there is this red squiggly underneath the, let's say, the variable that you are declaring. So these are easy to identify. Second error type is runtime errors. This is the one of the worst type of errors. These are the errors that crash your program. If, let's say, you're running your code and then suddenly somewhere in the processing of your code or the program, it just bumps out and displayed some kind of weird type of errors. So these are the runtime errors. Logical error. This is the very tricky one. These are the errors that give you a different result than you are expecting. This is an error in the program logic, which means that your code will run fine, but unless you see the results, unless you investigate on the report, for example, then that is where you will discover that you have some logical errors or logic errors. So in the next video, we're going to see how each of these error type occurs in our program. I'll see you there. Okay, let us now start debugging. I have created a new project called debugging. So in this code here, we have one method called display numbers. And the objective is basically to just display whatever numbers we have in our array. And we'll examine the results. So let's give it a try first. We have here 5 numbers, but we are only getting 4 results. Why is that happening? So there is no error in the code. I mean, there is no runtime error that it bumps out. It's just showing incorrect results. So let us investigate. To start debugging, we should create a breakpoint. So just by clicking on the left side here on the line of code that you would like to debug, it creates a solid dot in red, and then you can start the project again, and you see the highlighted line of code here with the arrow, which means that it's stopped on that breakpoint. Now we have these new icons called step into or F11, step over or F10, and step out or shift F11. So let's do the step into. Let's just click on this. Now we are in this method. So by just pressing the F10, step over, we can go line by line, but we cannot see what's going on unless we create a watch. A watch means so you can see the values in the variables. So to create a watch, just highlight the variable name, right click, and click on add watch in the context menu here, and it shows you the value. So if you expand this numbers variable, you have here all the results, the values here. Okay, next watch I would like to add is the I. So currently it's 0 because this expression hasn't been executed yet. And another watch that I would like to add is this one here, because this is the one that we see on screen. So at least we know what the value is. Okay, so by just seeing on the watches here, we can already see something. We can notice something already. So let's press F10 or step into, or I mean step over, so we can go to the next expression and go to the next line of code. Look at the numbers. This is the first iteration that we are doing, so it displays the first results, which is numbers I is 6. So the value of item is 6. Based on that, we can notice already that there's something wrong already there. Why is it picking up the second item in the array? Why is it not picking up the first item? Based on that, it means that the value of I that we initialize here should not be 1, but instead should be 0. Because you remember in C#, the arrays are 0 based, which means that they start from 0, 1, 2, 3, 4. Okay, so after seeing the values of our variables here, we know that the I is the problem. So let's press F5. So these are our results. Now we can change this initialization to 0, from 1 to 0, and then we can get rid of the breakpoint by just clicking on the red dot here. And let's run the program one more time. There you go. So now we're getting the correct results. So that's how you go with debugging, by inspecting each variable values. You can see right away that there's something wrong there, and you might notice that it's starting from the second element of the array. Okay, so in the next video we are going to see some other logical errors, and I'll see you there. Alright, let's have one more exercise for the debugging. I have created here a method called debug exercise 2, which is being called from the main, and this method is also calling another method, the check membership method. This is our check membership method here. Basically, the objective of this program is to validate the member if he is a member of the club. So in our case, we just hard-coded the names or the members. In the real world, this should come from database or some other sources, but in our case, let's just have 5 members that we can validate from. So let us run the code and see how it works. If I type in here name Ben, so the message is now Ben is not a club member because Ben is not in one of these lists in the array. He's not one of these members here, so that's fine. But if we run again and I type in Amy, Amy is not a club member, but Amy is here. So let's discover what's happening, and let's find where the problem is. So to start debugging, as usual, we have to create a breakpoint here. I'm interested in this particular line, so we can step through the code and investigate the values. Let's start again. So enter name to validate membership. Let's say Amy. Okay, so we press F11 so we can go into this method, and then press F10. By the way, we passed on the name here, okay? And we initialize isMember as a boolean, initialize it to false. Then we loop through the array by using the Foreach loop, getting each of the numbers in the array. So now the first one is we have Michael. Is Michael equals Amy? No. So we loop again. Now we have John, and we are comparing it to Amy. Next, we now have Amy, and this one is Amy. But you notice the case. This is all lowercase, and this is the S is A is capitalized. In C#, it is a case-sensitive language, which means that Amy with all small letters is not the same as Amy with the proper case letter, or proper case name. So this one will never be satisfied. Okay? We did not even add watch, because just by hovering over the variable name, we can see the values there. But if you are debugging some complex code, you might have to create a watch here. Alright, and then just see why they are, or you can actually put this watch, I think you can put this as a watch also. So it says false. Alright, so let's press F5, and then we know the results already because the condition was never satisfied. So how are we going to fix this? In order to fix this, we should make these two variables have the same results. So there are two ways. The first one is to lower, convert this to lower, and also convert this to lower. In that way, they are now both small letters. So let's give it a try. Let me get rid of this so we can go directly here. Let's say Amy or John. Okay, so S, let's add a watch for this one, equals John, and name to lower is also John. So now this is true. That's why we got here true. So isMember equals true, and then yeah, so now it's true, so we return the true. But the proper way actually is to break. Once we got this membership that true, then we should break the loop right away. In this case, we are still continuing to loop. This is good because we are only having 5 arrays here, 5 names in the array. Otherwise, if we have hundreds or thousands or even more, then it will keep on looping. So now we have the results here. Yes, John is a club member. Okay, so let me correct that. We should break once we get the membership. we should break right away, exit the loop right away. Okay, so that's how you do the debugging in this particular scenario. Make note that C# is a case sensitive language, so although they have the same name, if they have different cases, then they are not the same. Alright, I'll see you in the next video. Okay, so let us have one more example in debugging. This time, same as before, we are going to discover where the problem is, whether is it a runtime error or logical error. So in this case, I would like to emphasize on the logical error. I have created a method called debug exercise 3 with all this code here. The objective is to calculate the payment on a monthly basis for the amount and the rate, the interest rate based on the loan. So let's give this a try and see the results first. By the way, I have created also a method called calculate payment, accepting the amount to calculate and the interest rate or the percentage rate of the loan. And I have created here an enum, the different payment types. We have quarterly, we have monthly, we have weekly. So for example, you are working in a car dealership and you are asked to write a code that will calculate the interest payment. So let's give this a try. Our value here is $10,000, the amount of loan that we give the customer, and the interest rate is 3%. So we calculate it and we give the input. The amount you have to pay every month is $2,575. Wow, that's kind of big for a 10,000 loan. So your customer might be shocked. Really? $2,575 per month for a $10,000 loan. There's something wrong here, okay? So let us find the problem. Let's put a breakpoint again here and run the code one more time. Let me just get rid of all these watches. We won't be needing this. These are from the previous exercise. And let's create a new watch. Okay, so now let's press F11 so we can go into this method. We have here 10,000 and we have here 3%. We have the divisor for the percentage and the result initialized to 0.0 I mean. And this is the calculation formula. We have the amount times 1 point something, 1.03, okay? And then we divide the result based on the number of payments. See this one here? Based on this calculation here, which is, it uses the quarterly. So the result now, this is the total amount actually. Let's watch the result. So this is now, you have interest of $300. Okay, so if we calculate now, the result become $2,575 per month, which is very high. So based on this code here, you can see right away that there's a problem. Alright, so let's press F5 to continue the program. And this is what we've got. So which is wrong. Now we know where to fix it. So we incorrectly put the quarterly here instead of instead of monthly. So we should be using monthly rather than quarterly. So it will use the number 12 here. Okay, so let's start one more time. And we press F11. Result now will be 858.333. So that is more reasonable. Okay? Because sometimes in your code, if it gets too complex, and if you have these types of enumeration, sometimes you accidentally choose the wrong value and it will give you a wrong results. So you have to be very careful with that. Okay, so that's all for debugging. What we've learned is to create a breakpoint, to examine the value of the variables in the watch window, and also to check the logic in the code if it's using the correct variable or the value. So I think now you have a good understanding of debugging. Okay, I'll see you in the next topic. Hi, in this lecture we're going to discuss about error or exception handling. So what is error or exception handling? Error handling refers to the anticipation, detection, and resolution of programming errors. It helps in handling both hardware and software errors gracefully and helps execution to resume when interrupted. In programming, a development error is one that can be prevented. Such an error can occur in syntax or logic. This is what we've learned from the previous lecture in the debugging lecture. So syntax errors are typographical mistakes or improper use of special characters, or maybe wrong variable data type assignment, while logic errors, also called bugs, occur when executed code does not produce the expected or desired result. The C# language exception handling features help you deal with any unexpected or exceptional situations that occur when a program is running. Exception handling uses the try, catch, and finally keywords to try actions that may not succeed, to handle failures when you decide that it is reasonable to do so, and to clean up resources afterward, or maybe to log the errors into a file. So in the next video we're going to see how this exception handling happens in the program, or how are they being used in a program. So I'll see you there. Welcome to this demo. In this demo we're going to explore about exception handling. So I created another project called exception handling. The very first method that we're going to try is one of the most common exception that the programmers encountered. It is called the divide by zero exception. That means that you are dividing a number with 0, which is not valid. So it throws an exception. So let's give it a try. Let's see how it behaves in our code. So let me just create one method here called divide by zero exception exercise. And if we just hover over, we can generate the method for this. Okay. So let's declare one integer variable. Let's say integer I equals 2. And then another integer called result. This will hold the value of the result of our division. let's say 12 divided by I, and then let's just write to the console whatever the result is. The result is, then we just display the result, that to string. Okay, so from our main program we're calling this method here. Let me just provide here a console.read read key so we can see the output. Let us play this code. Start. Yep, the result is 6, so there's no error. However, if we change this to 0, for example, what do we expect now? Let's run it again. Yep, so Visual Studio is complaining about the divide by 0 exception, attempted to divide by 0. And this is what we see if we are debugging. However, if let's say we have compiled our code and we distribute to the users and they execute the exe file, let's see what they see. So let me just recompile this code, and let me show you the exe file. So this is the executable file. This is located in this folder, wherever you created your folder, and then in the bin debug there is an exe file here. So if we double click this one here, see the message? This is not pleasing to the eye of the users, and it's not also good for the programmer. So how can we handle this? As discussed in the previous video, when you are doing the handling of exception, you have to use the try catch block. So type in try and enter. Tab twice, and it will create for you this block here. So let me put this over into the try block. Okay, and then this is where we catch the exception. Let me declare a variable here, ex, for the exception, and then we can handle it nicely here. So let's say you can put here console.writeLine. Let's say you are dividing by 0, just to inform the user that you are dividing by 0. That's not correct. Or you can provide your own message. And then when you are using a try catch block, you can actually provide as many catch section as you want, but in this example we're just going to use 2. One is specific to the divide by 0 exception, so this is a built-in exception by C#. And another catch block that we are going to create is the generic catch exception and ex. So any error will catch other than the divide by 0. So console.writeLine, let's say just put here error encountered, whatever it might be. Then we can put here ex.message, so we know what's happening, what type of error we encountered. But it will already intercept by this catch expression here, because it's what's happening. So we can put a breakpoint, and if we run the code again, bam, which means that this one happened, see, and it goes directly to the catch block where we can display a more user-friendly message to the user. So if I press F5 to continue the application, it says you are dividing by 0, and then the actual error message is this one here. Okay, so that is one way to catch the error, specific error exception message, depending on your code logic here. Okay, in the next video we're going to explore the index out of bounds exception. That is another very common error message that the developers encountered. Okay, I'll see you there. Welcome back. In this demo we're going to explore the index out of bound exception. So let me just comment out this method here and let's create a new one. Let's call that index out of range or out of bounds exception exercise. Let's hover over so we can generate the method. Okay, so what does this mean? Let's say you have an array, for example, and you declare a certain number of elements that you can store in an array, and then instead of putting the exact number of elements, you added more, for example, which means you overloaded the array, or you reached the maximum item in the array and you still put some more. So let's do that. For example, we declare an array of numbers equals new integer 3, which means that we are expecting to add 3 elements in our array. So let's say the first one is it is 0 based. Just for your information, the array in C# is 0 based, which means 0 is the first element. Let's say we have 2, and then numbers 1, we have, let's say, 9, and then the numbers 2 equals 5, and numbers 3 equals 7. And let's say we would like to display the numbers. So we iterate using the Foreach loop, int I in numbers. Then we just display to the user the current number is and plus I. Okay, so what are we expecting here? Let me just run this program and let's see the outcome. There you go. So the error that we are seeing here, it says index was outside the bounds of the array, because we only created 3 and then we added 4. That's why the compiler complained. Okay, so how to handle that? For example, let me just comment out this one line here and we play the program. The current number is 2, the current number is 9, the current number is 5. It should be a right line so we can see it on a separate line. 295. Okay, but this is not, I mean, this doesn't happen very often. sometimes you happen to extend the numbers of array. So in this case we have an error. So to do that, we just have to do the same thing as the previous error handler that we've created. We have to put that in a try-catch block. So all of this code here goes into the try-catch block, the try block, the try section. And then in the exception, there is also another exception object built in for this type of array. It's called index out of range, and let's say we have the EX there, and then we can display to the user console that write line, and let's say array overloaded, for example, or you can just provide any message you have. And then if we create another generic catch section here that is for any other error other than index out of range, so we just have to put here exception, and then you can just say error encountered. Okay, and then ex dot message. There you go. So let's run this program again and see if oops, there's an error. Yep, we missed the semicolon here at the end of this line. Okay, let's try one more time. Array overloaded, which means that after it bump out in here, it goes directly into the catch index out of range exception. Alright, so that's how you use it. This one is complaining because we did not use the EX. That's fine, or you can just add it here, something like ex.message, so it won't complain anymore. So that's just how to handle the index out of range exception, but it's always better be careful with the number of elements in the array when you are declaring one. So this one should never be existed at all. In that case, this code will just do what it's supposed to do without any error. But that doesn't I mean, once in a while you tend to forget the number of array you are declaring, especially when the code becomes complex. Alright, in the next video we're going to discuss about the file not found exception. I'll see you there. Okay, welcome to our third and final video for the exception handling. In this video we're going to explore the file not found exception. Let's create another method called file not found exception exercise, and let's generate this method. Hover over and then click on this down arrow. Okay, but for this method we are going to pass on a parameter, the file name. So we'll be accepting the file name here, and from this calling method we should be passing the file name. So let me write here the path of the file that we're going to read. I have created a file called test.txt from this temp folder, and that is what we are going to read. Okay, so this method will read this file and return back the content to the calling method. So let me create a variable here called string contents, this will be the variable that will store whatever the contents of the file. First, let me show you the file that we are going to read. It's in this folder, and this is the file name. So it has just 3 lines of information here. The quick brown fox jumps over the lazy dog. That should be the one that we are going to see once we run the program. So let's continue building on this method here. But in this case, it should be returning a string instead of void. And from our calling method, we should have a variable that will store the value that is being returned from this method. So let me also call that as contents equals, and then we're going to display that content to the user. And that's it for this method here. And then let's continue building this method. So what do we need for reading a file? We need a file stream, and we need a stream reader objects. So let me declare one file stream. The stream is basically used to open the file, and the stream reader is to read the content of the file. So the file stream, let's call that as stream equals null, and another one is the stream reader. Let's call that as file. Also, let's initialize it to null as well. And now, by the way, before we continue, let me just point out that these objects here is coming from the system.io. Okay? If you comment out this won't be recognized anymore. So just make note of that. Okay? So now we can create our try catch block. So try tab tab. So the first exception, or the catch exception, is we are going to handle here the file not found exception, and then we also initialize this ex variable, and then we just message the user that the file is not available or not found, and then ex that message. And another one is the generic error. Let's say just exception ex, just in case there are some other errors other than file not found. Console.writeLine error encountered plus ex that message. Okay. So there is one more thing that we need to add, the finally, but let's just continue with coding here for reading the file. So stream equals new file stream, and we will need this overload method, the path, the file mode, and the file access. So the path name, the string path, is the file name. That's the one that's being passed in here. And then the file mode dot open, we are opening the file, and then the file access that we are reading the file. And now we can read the content of the file. The file now would be the new stream reader, and that will be the stream. And then we can store the contents into the contents variable. So file that read to end, which means that all the content of the file will be read. Okay. The method here is still complaining because we are not returning the value of the contents. So in here, let me just return the contents. Okay. Let's run this program and see what's the result. There you go. The quick brown fox jumps over the lazy dog. All good. No error. However, if, for example, we change this file name here, the value of our parameter, change it to test2, for example, which doesn't exist, it will give us an error, and it will be catched by this catch expression here, file not found. The file is not available. But before I run this program, I would like to add the finally section. Do you remember from the overview of this topic? The try, catch, finally. The finally part is always executed, no matter what. So, the reason why I would like to introduce the finally in this example is that it's very important to close the file after you read it. Otherwise, it will cause some memory leak. So let's put the finally here. And now all of these variables here, these two that relates to the external file, should all be disposed of, which means that they should be properly handled and disposed of their memory allocation. Okay, so to do that, let's validate if stream is not equal to null, which means the stream has the content, then we are going to dispose it. Okay, same thing with the file. If file is not equal to null, because if it's null anyway, so don't bother to dispose it, which means that they have already been disposed properly. So only if they have content. So file.dispose. Alright, so that's it. Now we have a complete try, catch, and finally block. So for the catch block, we have two: the specific error, the exception to handle the file not found exception, and the other one is just the generic one, which captures everything. And then finally, this is used to basically clear up the objects. If, for example, this part of code here is reading through a database, you make sure that the connection to the database is properly disposed of. Okay, and that is where you have to put in the finally section. Okay, so now let me put a breakpoint here. So we are passing a test2, which does not exist in this folder. We only have the test. Okay, so let's run our code. Yep, so the file name that we passed on is temp test2. Let me press F10. Yep, it already catched by this catch block here. Okay, so let's continue the code, and it should say file is not available. Yep, so we handled it properly. The file is not available. And then it should have been disposed of properly. If we provided here a breakpoint, it should continue. Let's say press F5 here, and it goes directly to the finally, because the finally block the finally section of the try-catch block is always executed, which means the stream is already null, so we don't need to dispose of, same as the file, so that's fine. And then return the contents, which has nothing, and that's why we display nothing, only the error message here. Alright, so that's how you handle the file not found exception, and that is how you add the finally section in the try-catch block. Basically, this is used to do some cleaning up of objects that you have declared from within your method, especially for the external reading of file or database connection or some other things. It should always be disposed of properly here. Alright, so that's all about for our exception handling. I hope now you have a good idea and you can apply it in your code. And that's all about it. I'll see you in the next section. Hi, welcome to this lecture, Introduction to Object-Oriented Programming, or OOP. This is a very interesting topic. So what does object-oriented or OOP means? It is a programming paradigm based on the concept of objects, which may contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. In OOP, computer programs are designed by making them out of objects that interact with one another. Objects are instances of classes, which typically also determine their type. There are three major concepts or components of object-oriented programming. The first one is encapsulation. What does encapsulation mean? It is wrapping up of a data member and a method together into a single unit or a class. It is called as encapsulation. It also means hiding the internal details of an object. In other words, how an object does something. It hides the data for security, such as making the variables private, and expose the property to access the private data that will be public. We will understand this when we go to the lab. We will have a clear explanation on this concept. So the next major component is inheritance. What is inheritance? It is a process of object reusability. When a class includes a property of another class, it is known as inheritance. So inheritance enables you to create a new class that reuses, extends, and modifies the behavior that is defined in another class. The class whose members are inherited is called the base class, and the class that inherits those members is called the derived class. We will also have a separate lecture or lab on this one, so that you will have a solid understanding on how to inherit an object. And the next concept or component of OOP is polymorphism. What does polymorphism means? Polymorphism means one name, many forms, which means that one function behaves in different forms. So in other words, many forms of a single object is called polymorphism. So there are two types of polymorphism. First one is overriding methods, and the other one is overloading methods. So we have a separate lab on this topic, and we will see the difference between overriding and overloading. What does this each of these method means? Okay, so I'll see you in the next video. Welcome to this demo. In this demo we're going to learn how encapsulation works. So let's get started. Let us create a new project called OOP intro. Let's just select here a console application. Call this as OOP intro. We will use this project to create the program for encapsulation, inheritance, and polymorphism. So while the project is getting created, when we speak of encapsulation based on the previous video, it is wrapping up a data member and a method together into a single unit, which is called a class. Also, it means hiding the internal details of an object. In other words, how does object does something. And the third one is it hides the data for security, such as making the variables private and expose the property to access the private data that will be public. So first things first, before we start creating our program here, we need to create a new object. So let's add a new class. Let me call this as a person. It's a person object or person class. So here it is. The first one is we need to create fields or private fields. So let's start creating some fields now. Let's just start with the first name, and we can provide a default value here. Let's just call it default first name. Another one is last name. Okay, and the third field is integer age. Let's provide a default value of 20. Okay, so these are all our fields: first name, last name, age, and they are all private, which means that this cannot be accessed from an instance of a class. Okay, you will see it later on once we instantiate this person class in our program here. So for now, let's also create a new constructor. So public person. Let's create two constructors where the user can just instantiate a person without providing all this information. The other one is public person. Now we ask the user to provide the first name. Also provide the last name. As well as the age. And then whatever they provided in here, we can initialize or supply it to our local variables here. So first name now would be the first name provided, and the last name now would be the last name provided, and so with the age. Alright, so now you notice these are all both public, which means that the user can see these two once they instantiate a person object. Next, let us create a public method that will display the person info. So public, let's just make it void display person info. All we have to do is just console that right line and provide here the, let's say, the full name. Your full name is, let us use the string formatter, 0, 1, and your age is, this will be 2, and then we supply all of these 0, 1, 2 values, which is the first name, last name, and age. Okay, this one can be, let me just show you another way to do this. This can be written something like your first name is, and you provide a plus sign there, and first name. I mean, it says here your full name is first name, and we concatenate the last name. Provide a space, then last name, and your age is plus age, something like that. But since the age is declared as integer here, we need to put it to string here so that it will be concatenated properly. So I prefer this method, is easier rather than this one here. So let me just comment this one out, and we are going to use this. Okay, so we have our person class. Now let's see how it works in our program here. So before we can provide some information, we have to instantiate first the object. So person, let's say person1 equals new person. So you can see here there are two overloaded methods, which means the first one is without supplying any values here. The other one is the first name, last name, and age. These are the constructors. So the first one is this one here without any parameters required, and the other one is this one. All right. So let us just use the default, and then we can now access the person1 dot. See this method here, display person info. But you notice that other than this method, there's no other properties or fields exposed. These are all defined in the .NET native functionality, or its default every time you create a class. But in our custom class, this is just the only method that is being exposed. Okay, so let's say let's see how it works. There you go. Let's just provide here a console that read line. All right, let's try one more time. Okay, so what we have here are all the default values only. This is the default first name, last name, and age is 20. Okay, now if we're going to use the second what do you call that one, the second constructor. So let's say person 1, I mean person 1, new person, and we provide the information here like John, last name is Smith, and the age is 32. Then we run the program again. We are now getting all these values. Okay, so that's how you create an encapsulation. You provided a private methods, and you only exposed a public one that accesses or uses all this information provided in the constructor. In the next video, we will further discuss about the encapsulation for another example, and I'll see you there. Alright, let's continue building on our previous project. In this lab, we're going to create 2 new methods, one public and one private, and the other topic that we're going to discuss is properties. So let's start with the properties. To declare properties, all you have to do is type in prop and click the tab twice, then specify your data type, let's say in this case string, and then first name. The other one is string and last name, and the other one is integer and age. So what are properties? Properties actually combine aspects of both fields and methods. So to the user of an object, a property appears to be a field. So accessing the property requires the same syntax. To the implementer of a class, a property is one of 2 code blocks representing a get accessor and or the set accessor. The code block for the get accessor is executed when the property is read. The code block for the set accessor is executed when the property is assigned a new value. Basically, a property without a set, let's say this one here, is considered a read-only. While on the other hand, if the property does not have a get, it means it's just a write-only. Okay? So we will see this later on once we start using this new class with all these properties. Another one I would like to emphasize on the properties is, another advantage is the validation. So you can control the input that the user is providing in your object. Let's say for the first name, for the get, we will only accept if the value is less than, for the set, we will only accept if the value is less than 20, because they can type in as many characters as they want, right? But in our case, let's say we have a business requirement to basically accept only a length of 20 for the first name, not more than that, and also not a null value. So we can provide a condition here to validate the value that is provided by the user. So the value is a keyword, is a native keyword. So if the length is less than or equal to 20 and the value is not equal to null, which means that the user provided a correct value, then we assign it to our first name. Okay, otherwise it will accept the default. And for the get, this is basically the user is retrieving the data, so all we have to do is return the first name. So that's how the getter and the setter work. Alright, in this case here we provided both, but there is no validation, so it's up to your requirement if you need to provide some validation or not. But in this case, we're just allowing the user to retrieve the data from this object as well as set the data. Same is true with the age. But in the first name, we implemented a business logic here to control the length of the first name to just 20, and it should not be null. Okay? So we can, before we try this in the program, let me just create another requirement here for our class to create two more methods. First one is public string do work, and this will be an exposed method. So do some other work here. Let's call that do work privately. Let's create a method for this one here. Okay. So in this case, let's just create a series of console.writeLine. Let's say I do gardening. We will use this example later on when we move over to inheritance and polymorphism. Console.writeLine, I clean the house. Console.writeLine, I walk the dog. And this is just done privately. This is not exposed. But in here, since we declared it as string, we need to return a value. So in that, let's just return a general work that you do. I do general labor work. Alright, so we have two new methods. One is private, which is called by the do work public method, and then we created the properties. Now let us use this in our program. So let me comment out this first example that we had earlier. Let us call now an instance of person. Let me call that person2 new, let's call it person3 new person. Okay, now person3 dot first name. Let's say we provided here John and more than 20 characters. Okay, I think this should be more than 20. And person3 dot last name equals Smith. person3.age equals 25. Okay, now we can just display the information. First name is person3.firstname. Another one, last name is person.lastname. And then the age, that right line, age is person3.age. Okay, now let's call the method person3.display person info. Save this program. Alright, so what shall we expect here? We have a validation for the first name that it should only accept 20 maximum characters. Should we see this one or no? Let's see how the program translates our code. Okay, so you notice that it accepts the default value, which means that this input here was not considered because it's more than 20 characters. Okay, so that's how to use the properties. You can control the user's input, so you have a clean data that you are going to process later on. Okay, so let us add one more call here for the new method that we just created, that do work. Right? Let's try running the program again. I do gardening, I clean the house, I walk the dog. So it executes all of these tasks here that we have created. Okay, we missed the right line here instead of, yeah, okay. So that is about it for the encapsulation. So in this video we learned how to use the properties, how to put some validation on the properties. We also learned how to create methods, both the private and public. So the private method can only be called from within the class, while the public method is the one exposed in the object, as we see here. Alright, so in the next video, we're going to discuss about inheritance. I'll see you there. Welcome to this demo. So in this demo, we're going to see how inheritance works. So let's get going. We will be working on the previous project that we started using the encapsulation. So we will just build on top of this one. So initially we created a class called person, and we have a public methods and private methods, and we also created public properties and also some fields. I made some changes on the last name and age to be the same as the first name, except that there is no validation. So we'll just accept whatever the user inputs during the initialization of the class or instantiation of the class. So we are going to create a new class that will inherit from this person class. First up, let me just add one more class. Let's call this as a doctor. So to do the inheritance, you just basically have to put in the colon and then the class that you would like to inherit from. So now in this case, the person is our base class and the doctor is our derived class. Okay? Which means that this doctor class now have all the methods and properties from the person class. We will see them all when we instantiate a doctor class. But for now, we can already extend the functionality of the person. So basically, we can create some new properties that's specific to the doctor object. So let's do that. Let's say we create a new property called specialty, so that we know the doctor's specialty, what does the doctor specialize on. And let's create a new constructor. This is without any parameters, and the other one is doctor with the first name and the last name, age, and specialty. Okay, so now the first name would be this first name here, and then the last name would be the last name that's being passed by the user, and then the age is the age, and specialty equals the one that is passed by the user, specialty. So let's examine first all of these fields or properties. You might notice if you just hover over, there is this information here that says this is coming from the person class. See, person, that first name. Same is true with the last name. Also the age, and the specialty is coming from the doctor, which means that this property only exists from the doctor class. So now we can instantiate this new class already. We are ready to use this class because we all have the person methods and properties. So let's give that a try. I just commented out the previous exercises that we had. So now let's instantiate the doctor. Let's say doctor1 equals new doctor. Let's give it the name of, let's call him Jeff Daniels. Age is 38 and specialty is, let's say, oncology. Now we can access those information, that right line for example. I am a doctor and my specialty is Doctor 1, that is specialty. And now if we call on the method that we inherited from the person, Doctor 1, that, see all of this came from the person, this came from the person also, and all this except the specialty. So doctor that display person info, and also the doctor 1 that do work. So that's it. Now let's run our program. There you go. So we are able to access the method from the person class. All we've created is a doctor with the constructor, and we're able to access all those other properties. Okay, So in the next video, we'll have one more example for this encapsulation, or I mean inheritance, and I'll see you there. Let us continue with our inheritance demo. So in this demo, we're going to create one more class that will inherit from the person. So let's do that now. Let's add a new class. Let's call this as engineer. Okay, so the way to inherit is just basically put a semicolon and type in the class to inherit from. Okay, and now we can also create a property that's just specific to this engineer class. Let's say string, let's say put it a degree. Then we create a two constructor, the one without any parameters passed. Okay, and the other one is with all those parameters passed, like first name, last name, age, and the degree. Okay, so first name equals first name, last name equals last name, and age equals age. This should be from the person, and then the degree equals degree. Okay, so that's it for our engineer class. Same thing as before. These are all from the person, and this is just from the engineer class. So let us create an instance of engineer in our program. This time we're using just for the first constructor without any parameters here, and then we'll just supply the property. Let's say Jimmy, let's say Chan, let's say 35. The degree is let's say structural engineering. Alright, now we can create a console.write line. And just say I am an engineer and my degree is engineer 1 degree. And then we can call on the display info person info method from the person class, and also the do work from the person class as well. So let's give this a try. There you go. So this is the first example we had, and now I am an engineer and my degree is structural engineering. Your full name is Jimmy Chan and your age is 25, and you also do a lot of this work. So that's it for inheritance. It's always advisable or preferable to create one separate class for each of, separate class file for easy maintenance of your code, rather than just create them in one single class file. So this is the recommended one, because the more your code gets complex, it's always easy to refer to just one class rather than in one single class file with all of these classes declared. Alright, so that's about for inheritance. In the next video, we're going to explore the polymorphism. I'll see you there. Okay, now let us discuss about polymorphism. This is the last component or concept of object-oriented programming. So what is polymorphism? It means one name, many forms, which means that one function behaves in different forms. So there are two types of polymorphism. One is overriding methods and the other one is overloading methods. So let's continue working on our project. So we have here our doctor class, and we are going to override the do work method. So override the method. Let us declare our method name do work. So we will be doing the work that the doctor do rather than the person do in general. So let's have here some comment. Do some specific work for the doctor. So let's say do work privately Let's generate a method for that. Okay, so in this method, what we're going to display is only those work that are that are the doctors doing. So let's say I prescribe medication. Another one is I perform surgery. And let's just return an empty string here. Okay, so that's it, which means that we have overridden the do work from the person object. So if we check what the person do work method does is I do gardening, I clean the house, I walk the dog. But the doctor, I prescribe medication, I perform surgery. Okay? By the way, the private method is only available in the class that you declared. So although you have a do work privately here, but it is private. At the same time, you also have do work privately here, which is also private. So they are entirely independent or different from each other. Okay, so now in our program, we don't need to change anything. Let me just comment out the engineer for now. So it's still displaying the person info from the person class, but the do work method now is coming from the doctor now. See? Doctor that do work. So we don't be doing gardening, we don't be doing cleaning the house or walking the dog. Now we are prescribing medication and performing surgery. So let's give this a try. There you go. So you are a doctor, specialty is oncology, and your name is Jeff Daniels, age 38, and you prescribe medication, you perform surgery. That's what the doctors do. Okay? So another method is, another concept of polymorphism is overloading method. So how does overloading work? Overloading means the same method name but with different signature. Okay, so let's create another overloaded method. Let's call this as public string. That's the same method name, but this time we have one parameter. That's it. Let's just put here number of times. So basically we're just looping or iterating the how many times the doctor perform an operation, for example. So for int I equals 1 and I is less than or equal to number of times, then we increment the I, and then we just write line. Let's say I perform operation how many times a day, and then this is our I. Let's just make it as simple as that, and then we return another string, and I'm tired. Okay, so we now have two methods for do work, but different signature. One does not have a parameter, the other one has an integer, number of times integer. So which means that this do work method is now overloaded. So if we go back to our program, now we can do let's capture the return string work equals doctor1 that do work. See, now there are two methods of do work. The first one is just similar to this one here without any parameters, and the other one has number of times. So let's say 5 times. And then now we captured the result of this do work. Let's go back to the definition. So it returns this string here, okay? Because it returns a string value. So other than performing an iteration how many times, it also returns this value here. So let us capture that into a work variable, and then we console that write line and put that work. Okay, so let's give this a try. We have an error. That's the error. There is error here. We don't need the length. Okay, so let's try one more time. we have another error here. It's a typo. It should be, let's just stop the program first and then correct this error. So now I think we should be good. Let's give it one last try. Here you go. So this is our first example, and then this is our overloaded method. I perform operation 1 time, 2 times, 3 times, 5 times a day, and I'm tired. Okay, so the same method name but different signature. Okay, so that's how overriding and overloading works. In the next video, we'll have one more example of this, just so you have a solid understanding on how it works. So I'll see you there. Welcome back to our polymorphism demo. Let's continue working on the engineer class. So in this lab, we are just going to override the do work method from the person. We're not doing any overload, so just the overriding the method. So public, this time we're not going to return any string, just void and do work. Then we'll create a private private method. Okay, so in this method we'll just do the same thing from the doctor, but it's specific to the engineer's work. Let's say I create engineering design. I oversee construction projects. So these are just the change that we're going to make here. But from the person, instead of returning a string, we are not going to return anything. All we need to do is do this method here. So from the program declaration, we are not changing anything. Let's uncomment this and let me comment out the doctor. So now this do work is getting it from the engineer class rather than from the person class. So if we run our code, there you go. So the engineer is not doing the gardening or cleaning the house or walking the dog. He is now creating engineering design or overseeing construction projects. Alright, so that's how polymorphism works. I hope you now have a solid understanding on the subject. Okay, I'll see you in the next video. Welcome to this lecture. In this lecture, we're going to discuss modifiers. So what are modifiers? Modifiers are used to modify declarations of types and type members. So an example of a modifier is a const, which means it's a constant. So it is used to declare a constant field or constant local. Constant fields and locals aren't variables and may not be modified, which means whatever you declared in them, that should be the value already in your code. So constants can be numbers, Boolean values or true and false, strings, or a null reference. For example, here we have a constant integer x equals 0, which means that throughout your code the value of x will always be 0. Another one here is the color index. This is a public declaration of the constant color index equals 1. Another one here is a private declaration of a constant string. Let's say app name is AutoCAD. So these are all constant declarations of the field. Okay, so they cannot be changed in your code. The value will always be whatever you declared it initially. Another keyword is the static modifier. A static class is basically the same as a non-static class, but there is one difference. A static class cannot be instantiated. In other words, you cannot use the new keyword to create a variable of the class type. Because there is no instance variable, you access the members of a static class by using the class name itself. So here's the example here. I created a class called calc, let's say calculator or something. Then we have one method which is declared as static integer public that accepts a two integer values, num1 and num2, and it returns the total of the two, the sum. So when you use the calc or the add method, you just use directly as calc.add and then pass on the integer values. Unlike in the class, you still have to declare with a new keyword, and this one here, but this is not applicable in static. So in static, whatever is the method, use it right away with the class name. So exactly like this. Okay. Another modifier is the access modifiers. These are keywords used to specify the declared accessibility of a member or a type. So these are the most commonly used modifiers: the public, private, protected, and internal. So in the next video, we are going to explore more on the access modifiers. I'll see you there. Let us now discuss access modifiers. Access modifiers are keywords used to specify the declared accessibility of a member or a type in the class. The most common access modifiers are public, private, protected, and internal. And there are a few more. So when you speak of public access is the most permissive access level. There are no restrictions on accessing public members. So in our example here, we have one variable or one property from within our my class. So this can be accessible from anywhere in your code. Once you declare an instance of the my class, then you can access this property. There is no restriction. And here we have a private. This is the opposite of public. Private access is the least permissive access level. Private members are accessible only within the body of the class or the struct in which they are declared. So in this example here, we have a class employee and we have a property called I with an integer type, and it says private. And we have another variable declaration here, or another property called D or double. So even though you don't declare here a private, that is private access by default. So these two declarations are the same. And again, this can only be accessed within the body of the class or the struct in which they are declared, nothing more. And we have here protected. Protected is the type or member can be accessed only by code in the same class or in a class that is derived from the class. So we have here a class called employee, and we have a method here called display name, which means that this method can only be accessible by the code in the same class, not outside of that class. And we have here internal. Internal, the type or member can be accessed by any code in the same assembly, but not from other assembly. In other words, internal types or members can be accessed from code that is part of the same compilation, which means that if you have another assembly or DLL file that you reference into your project, you cannot access those members or types that are declared internal. So in this example here, we have declared the IMAX internal, and it's static equals 10, which means that this can only be accessed from within the assembly of the code in your project. So in the next video, we're going to cover more of this. We can see the distinction between the accessibility levels or restrictions in a matrix. So I'll see you in the next video. Let us continue exploring access modifiers and understand better how they behave in certain conditions. So in the previous video, we learned about public, we learned about private and protected and internal. And in here we have two more additional access modifiers, the protected internal, which is basically a combination of a protected and internal. And we have here a private protected. So this matrix shows the restriction level or the accessibility level of the properties or methods, which are declared based on any of these access modifiers. So let's examine one by one. If you have declared a property or method from within the class, then they are all accessible. Any properties or methods which you declared with all these access modifiers from within the class, they are all accessible. From the derived class within the same assembly. Derived class, by the way, means that it is a class created from another class or created by inheriting from a base class, or sometimes called a superclass. Derived class is sometimes called a subclass or a child class. We will learn about this in the upcoming videos when we see the actual examples. So if you have that declaration of public and all of these other four, you can still access those properties or methods except the private. So again, private is the least permissive access level, which means that it's only accessible within the class, nothing more from within all of these different scenarios here. So the third one we have is non-derived class from within the same assembly, which means that this is the class, the base class that you have created, and if you declare a property that is public or a method that is public, then it is accessible. Same is true with the protected internal and also in the internal. So the protected, private protected, and private are no longer accessible. And the fourth row here, we have derived class from within the different assembly, which means that this is from different DLL file that you are only referencing into your project. So again, even though it is from different assembly, if you declared a method or property that is public, then you can still access it. If you declare it as protected internal, then you can still access it. Even though you declare it as protected, you can still access it. And internal, private protected, and private is no longer accessible. And the fifth row here, we have non-derived class from different assembly. And in this scenario, only the public declared properties and methods are accessible. The rest are no longer accessible. Okay, so if you are designing a complex OOP project, then you have to consider all of these different access modifiers. So depending on your requirement, you might have to pick a access modifiers that is appropriate to your requirements. So in the next video, we are going to try this out in action. We're going to create a project, a solution, a simple one, but at least it showcases each of these different access modifiers in action. I'll see you there. Now that we have a good understanding of access modifiers, let us now create a project so that it will solidify your understanding. So open up your Visual Studio and click on Create a New Project. And in here, make sure you select C# and type in console application and select the console app.NET framework. Click on next, and let's call this as access modifiers, and let's put it in this my projects folder. For the solution, let me just rename this to access modifiers solution. And if you hover over here, it says a solution is a container for one or more projects in Visual Studio. And click on Create. So this will create the console application for us. Then we can start building the project. Let us now create a class, a new class. So right click and click on Add and Class. Let me call this as, let's say we call this as my AutoCAD object. Let's just mimic the way AutoCAD works in a very simplistic way. I would just like to show you the relationship between the objects in the derived classes and the base class. So let's just create this my AutoCAD object, and in this class we're going to create one property and one method. So let's say, let me call this property as this string, and we call this as layer. Every single AutoCAD object has a layer, so that is our property. And then we will create a method called display layer. So public void display layer. All this function does is to display whatever the layer name that is assigned in this property. So let's just display that in our console window, console.writeLine, and then we put here the layer is, and we concatenate the layer. Okay, and we have here another console.read key, so that we can see the output on the screen. Alright, so from this matrix here, we're just going to cover the first row from within the class. So we're going to try all of these access modifiers in our property, in our layer property. So now currently it is set as public, which means that we can access that layer here from within the same class. Okay, so now if I change this to protected internal, still I can access the layer. If I change this to, what's the next one, protected, then still we can access the layer property. If we change this to internal, same thing. If we change this to private, then it's still accessible. If we remove this private, by default it is private and we still able to access it, no problem, right? Because they are in the same class. So all of these access modifiers here are allowed, no restriction. Okay, so now let us save our project and then do a build. So it is building. Now we have one succeeded. If we open our project here, we now have the access modifier solution, and this is our access modifier project. And in the bin folder, debug, we have here the exe, right? So that is our console application. If we run that, if we run this project, it will do nothing because we haven't called this AutoCAD object yet. In the main program, it's just a blank. Although we have created the class, but we've done nothing about it. We just created the property and a method. Okay, so we are done with the first row here, which is from within the class. We've seen that all of these access modifiers are allowed. No restriction. So in the next video, we're going to learn about this non-derived class from the same assembly, from within the same assembly. Okay, I'll see you there. Let's continue working on our project. In this video, we're going to focus on non-derived class from within the same assembly. So let's go back to our project. So now we have our AutoCAD object class, and from the main program we can now instantiate this class. So let's say AutoCAD object, and let me just call this as obj equals new AutoCAD object class. So now we have an instance of that class. If we now check the properties and methods of this object, we can see that we have here the display layer. So this is only the visible method because in our declaration we only have this one public. But let me just put this one as also public. And if we go back to our program.cs and we click on dot, we now have display layer and also the layer property. Okay, so those are accessible because both of them are public. So let me just do one thing here. Instead of flipping back over to my AutoCAD object class and program.cs file, I would like to make this class, I would like to move this over. So let me just copy this into the program.cs file and I'll put it here. Okay, this is just for demonstration purposes so that we don't keep on flipping from this program.cs file to my AutoCAD object.cs file. But this is the recommended approach, which means that every time you create a class, it has to be in a separate class file. That is because the class can get complicated very quickly. I mean, once you create lots of properties and methods, it can become complex, and you want it to contain in the same file rather than combining it into one class file. But for demonstration purposes, we'll just move it over here, and now we can delete this file here. Okay, so now we have our class in the same file. So easy for us to work on by changing the access modifiers of these properties and methods. So now it has the same behavior. Okay, so now we can see the layer, we can see the display layer. If we go back to the matrix, the non-derived class can only be accessible using the public, protected internal, and internal. So let's try those three access modifiers. So we tried the public already. Now if I change this to protected internal and we check the properties, we can still see it, right? Same thing with the method. So it applies to both. It applies to both the method and the properties. We also still have this display layer. Now if we change this to internal, and we type in the dot, you can still see it. Okay, if I change this one to, let's say, protected or private, protected or private, I won't be able to see that anymore. So private, for example, now I can only see the display layer because that is the protected internal. If I change this to private protected, same thing, I cannot see it. And if I change it to protected, then same thing. So those are the three access modifiers that you can use if you are using the non-derived class from within the same assembly. Okay, so that's it for the non-derived class. In the next video, we're going to explore more on this derived class. All right, I'll see you there. Let us now examine the derived class from within the same assembly. So if we look at the access modifiers here, all the 5 access modifiers here has no restriction. Only the private is restricted. So if we go back to our project here, let's see that in action. So we're going to create a new class that will inherit, that will derive from this class. Okay, so let's just call this as myLine. And again, this is not the recommended approach. This is just for demo purposes. The way you do this in your actual project is you create a separate class file for this one. Okay, it's just to avoid for us flipping from one file to another here. And in this myLine, we're going to create one method. So let's say public void, just call that a show layer, and we're going to make use of this existing layer property here. So now if we declare, so we haven't declared any method or properties here yet. So if we create an instance of myLine object, ln equals new myLine, and we type in ln dot, we can only see this show layer method because it is declared as public. Okay, now to inherit from other class, we have to put here colon, and then you type in the class name, in this case the AutoCAD object class. Okay, so now if we do another dot here, we can already access the layer and also the display layer from our base class or super class. And now our myLine here becomes a subclass or a child class because we are inheriting from our parent or base class. Okay, so since the focus of this video is to learn about the derived class from within the same assembly, let us now explore how we can access these properties and methods from within our derived class. So let's say we have here another console.writeLine to display the layer. The layer is, and we have here the layer console.read key. Okay, so if I change this access modifier from public to protected internal, our layer here is still accessible, right? So public is accessible, protected internal is accessible. If I change this to protected, we can still access the layer property here. If I change this to internal, we can still access the layer. If I change this to private, then now we have a problem. It says here, if we hover over, my AutoCAD object, that layer is inaccessible due to its protection level, right? So that is how this derived class in the same assembly works. Only the private is restricted. Alright, so if I change this back to, let's say, let's make it public, and then we declare our ln object here with, let's say, the layer. Let's say we call this as stairs, and then we call the ln.showLayer method. Okay, and we run our program. It should show us the layer is stairs. Okay, and that's it. That's it for our derived class in the same assembly access modifier works. So in the next video, we're going to explore on this non-derived class in a different assembly. I'll see you there. Okay, let us now learn non-derived class from different assembly. So if we look at the matrix here, only the public access modifier is allowed. The rest are all restricted. So let's go back to our project and understand how this works. By the way, when you speak of different assembly, this means this is coming from a different file or different compilation, different DLL file. So our project now just have the console application that we have created earlier. So we're going to create a new project from within this solution. So right click on the solution here and click on add and new project. And this time we are going to use a class library project, and we will select the class library.NET framework, and it will be stored in the same solution that we have created earlier. And let's call this as, let's say, P-line tools. Let's say we created a separate DLL file for the polyline tools, and click on create. So now we have this P-line tools project in our solution. If we go back to, if we examine this location folder here, we now have this P-line tools project. So this is the first project that we have created earlier, and now we have created this P-line tools. Okay. All right, so let me rename this class 1 here, and let's just call this as PL tools. Okay, so it will now be renamed to PL tools, and in this class we're just going to create one property and one method. So let's say we create a property here. Let's say we have a property called number of vertices, and we have also another method. Let's say void display number of vertices. And in this method, all we have to do is just display the number of vertices based on this property here. So the number of vertices are, then number of vertices, and then just put here console.read key. Okay. So these are now our properties and methods from these PL tools, from this P-line tools class library project. So now if let's just save this solution and let's do a build on this. Let's do a build. So currently, if we just go to the bin folder, we have the debug here. Nothing here, right? Because we haven't built the project yet. So if I do and build, Now we have here one succeeded, and if we go back to our folder, we now have here the DLL file, because this is a class library, so it compiled to a DLL file. Okay, so this DLL file now, we are going to reference this into our console application. So you go back to your Access Modifiers project and click on References, right click and add reference. Just before I do that, let me just go back to our main program here. Okay, before that, let me just comment this out. We don't need this anymore, because now we are talking about the file from different assembly. So in here, let's say I would like to initialize PL tools or P-line tools. I don't see any, because we haven't referenced yet the DLL. So if we now reference this DLL, we browse it, and we click on these PCs, go to C drive and My Projects. This is My Projects, and we have here the P-line tools. Go to Bin and Debug, and this is our P-line tools.dll. Okay, so now it is referenced. So if we go back to our main program here again, you can see that here we have the P-line tools. So now if let's say I would like to create an instance of that P-line tools, you can see it here. So let's say PLT equals new P-line tools. All right. What's the error that we are having here? It shows like used like a type. In our P-line tools, what we have here is it's a PL tools, not P-line tools. So PL tools, P-line tools.pl tools equals let's say PLT equals new P-line tools.pl tools. All right, so that is our instance of this PL tools object. So if you want to avoid using these P-line tools here, you can just put here using P-line tools, and now we can get rid of these P-line tools in our instantiation of the object. Okay, so if we type in the dot after the PLT dot, we can see that we have the number of vertices and we have the display number of vertices method, right? Because the declaration of this in our PL tools class is public, right? So these all work. If we, let's say I complete this, plt.number of vertices equals 5 and plt.display number of vertices, and if we run our code, it should display that there are 5, the number of vertices are 5, because we put here 5, right? So everything works if it's declared as public. However, now if we change this back to any of these, protected internal, private protected, and private, they won't work. So let's say start with protected internal. All right, and if we go back to our main program now, it says PL tools that number of vertices is inaccessible due to its protection level, and this applies to both method and property. So let's say we change this to protected internal also, and we go back to our main program. See, both of them are showing this error already. And if we change this to protected, same thing. If we change this to internal, same thing. If we change this to private protected, same thing. If we change to private, then nothing works, all right? Except change it to public. And you can see this, after I change to public, the number of vertices properties work, but still the method is still not working because it has a protected internal access modifier. So if I change this to public, then everything works fine again. Okay, so now that's how it works when you say it is a non-derived class, because we directly access the class and it's coming from different assembly, which means that it's coming from a separate DLL file that we just reference into our project. All right, in the next video, we're going to cover the derived class from different assembly. I'll see you there. All right, welcome back. Let us now learn more about derived class from different assembly. So in this matrix, we can only see that there are 3 access modifiers that allows access: public, protected, internal, and protected. The other 3, which are internal, private, protected, and private, do not have access. So let's go back to our project. So this is our PL tools from different assembly. And let's go back to our main program. And in here, we're going to create a new class, and then we are going to inherit from this PL tools class here. So let's create a new class called myPline, and we're going to inherit from PL tools. Okay, so if we create a method from here, let's say we call that method as show number of vertices. And now we should have access to the PL tools properties and method here, number of vertices and display number of vertices. So number of vertices, let's say 10. And now we can create a, let's say, console.writeLine. The number of vertices is, let's say, number of vertices. Console.readLine or read key. Okay. And see that we have access to the properties and methods. We can even call here directly the display number of vertices, which is coming from this PL tools method here, right? Because they are both declared as public. So now if we change this public to, let's say, protected, internal, and protected, we change this to protected internal, and I go back to our myPline class, we don't see any error. They're both valid or allowed. If I change this to protected, same thing. There is no warning or no squiggly. However, if I change this now to internal, now we should see the number of vertices is showing an error already. It says it is inaccessible due to its protection level. So same thing if we use the internal or private protected access modifier. Private protected. Right? And even more so on private. won't work unless we change this back to either of these 3 access modifiers again. So if I bring this back to protected, now it should work. Okay, so if we run this code, this program, it says here the number of vertices are 5, but this one here is calling from the original code that we have created earlier. This one here, right? This is from the first declaration that we had directly accessing the PL tools. So let's comment out this one here, and let me change this to, instead of PL tools, we are going to use the derived class. Okay, so my P line, my P line, let's say MPL equals new my P line, and MPL dot number of, or in here we don't have a separate property. All we have in this class is a method. So MPL dot show number of vertices. Okay, and if we run our program, now we have here the number of vertices is 10, and the other message is the number of vertices are 10, because in our show number of vertices method we have here our own console.write line, which is using is, the number of vertices is, and we also call the display number of vertices directly from the PL tools. We go to the definition, we also call this method directly from the derived class, which is using the R. Alright, so that's how the derived class from different assembly works. It is only accessible using these 3 access modifiers: public, protected internal, and protected. Okay, and with this concludes this topic on access modifiers. I hope you now have a clear understanding on how they work. All right. Congratulations for finishing this tutorial. Hopefully you learned something from it. Please subscribe and like to support this channel. Thank you.